really get anyone stumbling on our content very much anyways, but all right.
All right, hello and welcome to another Aether Round Table. This is episode number 10. We might have some guests joining us later, but to get us started here, I think we're just going to pick up off of our interesting conversation on LIGO before we get back into E equals MC squared or whatever we have for the agenda tonight. So yeah, Toby, you want to kick us off with
Yeah, so I'll just
with the LIGO?
sorry to be redundant.
Yeah.
Sorry to be redundant for like Beasticles and anyone else that's already listened in, but like I was on Twitter talking about the variance or invariance of the speed of light with some people and going back and forth, and I provided Dufour and Prunier and Ruyong Wang's experiment from 2004, and I was like, hey, look, it's not variable, or it's not showing variance, or it is showing variance depending on directionality and velocity of the rotating object or linear object, and or linearized motion. And anyways, this dude comes back with this experiment from 2015, some Nature article, and I start looking into it, and it used what was called error-weighted least squares regression, a statistical model, to account for daily fluctuations and seasonal changes and to fit the relativistic model. So basically, it actually used a statistical model to make it match their they're refining their whole thing. So that was like a big light bulb moment for me, because I've been contemplating LIGO and what's actually going on there. And when I realized that these dudes literally sat there and measured variance in the speed of light right in front of their faces. They took the measurements, and then they said, "Oh, look at this. We didn't get any variance in the speed of light," because they used the regression model afterwards, and they patted each other on the back for it and published it. And it's just insane to me. So then I started looking into LIGO, and I realized, holy cow, it's like we always talk about abstraction layers, and how every time that their prediction model is wrong, their model's predictions are wrong, they put a new abstraction layer over it. And this is it in our faces, because it goes from just like a regression model like that to, for the gravitational waves at LIGO, they're using a whole neural network. It's called a convoluted neural network that has layers and layers of what's called matched filtering applied to it. So basically they literally call it noise. They call the data noise, and they used a sample set of noise to find a gravitation wave before they even used real data to find a gravitation wave. So they call it noise, and then they run it through. But what the convoluted neural network does, the convoluted part means that it pulls the data across multiple dimensions, and then they're allowed to they then go through and filter those different dimensions for data that matches what their model is looking for, essentially what they're looking for. And so yeah, so it goes through it's all sorts of, if you read into the specifics of what it's doing, it's just insane levels of filtering, to the point where I'm pretty sure that I could just take a reading of my fart, and they'd find, if their neural network had enough time with it, they would find a gravitational wave eventually.
Isn't that what Alan said? Toby, if you farted in the general direction of a LIGO identifier, they'd be able to measure it.
They'd find it in there, and then Alan said that the speed of light would change too, though.
What's up, boy?
Yeah.
It depends on how noisy the fart is.
Does it though?
No, it'll just be in the data, bro, in perpetuity, rippling in forever, always trending towards zero, but never finding it.
But data
heat filtering was only trained on noise from other events. Therefore, our results demonstrate the ability for CNN, which stands for convoluted neural networks.
Does it say convoluted?
Convoluted, which is
literally they put it convoluted.
Yeah,
like needlessly redundant and self-serving iterative process. That's what we're gonna call it.
Oh, here we go. We have a demo here of the. Oh yeah, we need access. Rip. Right from their paper, there was a thing to a demo showing the deep filtering of the GW 115 or 150914 can be found here. So it was going to show us like a rendition of what Toby's talking about, but we need access to see it. So, rip.
We then tested the performance of deep filtering when a signal is superimposed with both a glitch and real LIGO noise. Like it's just like what level of noise?
What's the difference between real LIGO noise and a glitch, dog? Like, how would they ever know?
Dude, I think it's funny that they call their data noise. It's like, so here's what we're going to do. We don't have any data, but we're going to invent a convoluted, self-serving, self-iterative neural network that'll interpret this non-data. And from that non-data, we'll extract this data that matches our predefined model. And then we'll claim that this data corroborates our model later.
Yep. It's unfalsifiable.
And literally, we're going to name it our own convoluted, self-serving, fucking self-jerking data network.
Oh, man.
Dude, it literally calls it deep filtering. Like, holy shit.
Yeah. Deep filtering, and then it uses matched filtering as part of the deep filtering.
Dude, all I needed to do was like have Alan go over that one example of the first gravitational wave they detected and just like the brief historicity around it and then what led up to it. And then you can watch like the actual stream and you're like, okay, all right, this is all for fucking funsies, right? This is not real.
It's all for fun.
Search for gravitational wave signals in the data recorded by the detectors uses matched filtering. This compares the observed noisy data to predictions of signals from Einstein's general relativity. Matched
Truly.
filtering can pick out gravitational wave signals from noisy data in a way similar to how we can distinguish individual instruments in a piece of music. That's quite a stretch at the end there. That's
from a piece of music, dude. So check this out.
That's absurd.
This is let me pull up. That's the wrong one. Where's my Schwarzschild metric at? So this is your boy, the Schwarzschild metric. So when they talk about like where are they getting these predictions at, dude? So the frequency change in light is extrapolated from this. Now, not this particular metric because this is the Schwarzschild metric, which only describes a stationary, which will only describe the influence of a stationary mass. Yo, Blaze, what's up? Is she echoing?
Am I permanently on too?
Just Blaze. Anyway. So anyway, they use the what do they call it? The curve metric. So the curve metric describes two rotating objects and not just a singular rotating object. So they have a slightly different variation on how they calculate it. But basically, oh yeah, you're good, Blaze. It was just I wasn't sure if you were trying to talk. I'm sorry, I mean Blase. So anyway, they have their this is where they get it from, these metrics, right? So they can make a prediction based on someone. They're like, okay, this black hole must weigh
Post-diction then.
Post-diction, absolutely. I forgot that. Very important. So they get these post-dictions by saying, okay, we're looking out in the sky, or actually, I don't even think they looked out in the sky for this one. They just assume that somewhere this event happened where these two black holes of XYZ mass collided with each other and caused a ripple in the fabric of space-time that extends in perpetuity and up to modern times where these gentlemen have made laser interferometers to measure this. And so this is where it comes from. So it's like how much of this mass of this object will distort space-time around it so that when light interacts with it, when it's traveling nearby, how much is the frequency going to be shifted by it? Is basically what they're looking at. And so they have
hold on.
Mhm.
We don't want anyone to get confused and think that they might accidentally be actually measuring variance in the speed of light or anything like that. So you might want to be careful with that measuring word. We don't want to be throwing that around too much. We kind of want to we were interpreting before we're like the data is not actually being presented before it's being filtered. So can we even call it a measurement?
True. That's a really good point, because as we found out through the history of interferometry, right? There's a variance in C that matches sidereal time, and it doesn't matter if you're using an orthogonal setup, so the LIGO setup, classic Michelson-Morley, all that stuff, or if you're using a closed interferometer, so Michelson-Gale, Pierce, Sagnac, any closed loop circuit, anything like that. They all measure the same variance that can be plotted against sidereal time, where it shows minimum and maximum dimensions at the same time. So they never have anything else other than that. So what these gentlemen would have to have had corrected is that variance every day, which Toby was just saying, because the thing that they actually claim that they're measuring is way smaller. They say it's 1/1000th the width of a proton. So the daily fluctuation from the sidereal fluctuation is way greater than that, right? So they have to account for this. So Toby's going to go over how they even account for that before we even get to like, you know, a quote unquote raw data or white noise or anything like that. Just the calibration of the instrument is already erasing the daily variance in the speed of light that's been measured in time and time again to a degree of precision that would, you know, down to the nanometer, right? The small, like some of the smallest measurements that we can make, the most precision that we can get out of it. You know, so all right, go ahead and take it away, Toby.
Sure, yeah. So I mean, I'll just kind of go over what good old GPT and me were talking about earlier. So, in order to get your data through, or let's just imagine that you're a data set, right? Hi, I'm a data set from LIGO. Let's look at my journey. First, we're gonna go through the convolutional neural network. First, we're gonna go through the convolutional layers. These are the core building blocks of a CNN. They apply a number of filters to the input. Each filter activates certain features from the input, such as edges, textures, or more complex patterns in deeper layer. Or why don't I just share my screen?
Absolutely.
I was just about to ask you.
You weren't going from memory then?
This is GPT, man. So, each filter activates certain features from the input, such as edges, textures, or more complex patterns in deeper layers. So, going back to like they were talking about, so let me find where they explain what the convolutional part means.
Yeah, ask ChatGPT why the word convoluted is in its description of what it does in its neural network.
So, I mean, this kind of explains it here. CNNs are particularly suited for visual recognition tasks because they can capture spatial hierarchies in data. So basically, since it's not looking at a real picture, so there's not really any objects to look at, and it's just noise, and just like a computer can't really compare, it's just basically running the data through multiple dimensions of approaches of like interpretations of the data is the way I basically interpret that. Spatial hierarchies. So it's just like different ways to extrapolate the noise.
Or different ways to apply the noise, you mean? Like as
The
opposed
layers of CNN have neurons, which is I think it's so insane that they use that word. Arranged in 3 dimensions, width, height, and depth. Neurons in a layer will only be connected to a small region of the layer preceding it, which helps the blah, blah, blah. Anyways, let's go back to the layers. So first, we're going to highlight edges, textures, or more complex patterns that match our model. Then we're going to hit the ReLU layer, and that's going to introduce nonlinearity into the model, because obviously you got to have that, right? How else are you going to find your gravitational waves? Don't forget, we're doing experiments here. This is data from an experiment, allowing it to learn more complex patterns. You got to do that to do an experiment. Pooling layers. These layers reduce the spatial dimensions. So we just got in, we made all these dimensions. We picked out the parts of them that we liked, the patterns that made sense for us, right? These kind of match. And then now we're going to go back through and we're going to reduce the spatial dimensions of the input volume for the next convolutional layer. So basically, this is throwing bad data out, right? Let's get rid of that noise. To help decrease the computational load. Yeah, because why would you want a bunch of noise in your computational load? You just want to know specifically what matches your relativistic predictions. You don't want to see anything that says like, hey, light's constant or light's not constant.
just this noise, not that noise, you mean?
Yeah.
We're very selective about our choice of noise.
Like the maximum element of the region of the feature. It's just selection after selection after selection. Like it's like, how are you even in relation to the original data set once you get through all this? I mean, so we're just in the pooling layers, which was just throwing a bunch of stuff out. And then now we hit the fully connected layers. These layers are typically placed near the end of the CNN architectures before classification based on the features extracted by the convolutional layers. So I'm assuming that they then use that to even do more correlation based on those classifications to match their model. Then normalization layers such as batch normalization can be used to normalize the inputs of each. Oof. So then,
Yeah.
they're going to make a bunch. That's like assumptions are inherent, like massive assumptions are inherent in every step. Like every step. This is supposed to be experimental data, and it's going through this many layers of filtering.
Filtering. It's more like refinement. They're taking this unrefined chaos data, they're refining it through multitudes of predefined filters and subsequent like iterative networks where each node assumptively like makes some sort of tested derivation. Is this like what we want it to be? And then at the end they're left with only the noise that matches their predefined model. As you were going through it, I couldn't help but be reminded of like the geodesic surveyor debate on the main surveyor debate, and how he was like, well, here's what we do: we make measurements, and measurements that don't agree with the sphere, we throw those away. And then we take the measurements that agree with the sphere and we average them together. They're like, okay, but
Well,
what would
so
happen? Like, you know what I mean?
the insane thing to me here is like, with that, at least we're still using equations, so we at least have like they have a formula that they can point to and be like, hey, and we can at least be like, hey, what's happening with that? We can point to their formula and say, what is the mechanism of this formula, right? But when you're using like filtering like this on layers upon layers upon layers of filtering, like you're just detaching yourself from any actual assertion of reality every single step of the way. It's like like at least with that we can try to falsify it and say, hey, that's just kinematics. But with this, it's like it's way beyond that, because it's like kinematics with the assumption that the machines will eventually find the answer, like the real truth answer, and we never have to change our assumptions.
The computer will figure it out for us. Shane, are you speaking?
Oh, yeah, I can't hear you, Shane.
No, my shit's freaking out.
Okay, no worries. Yo, what up,
Yeah,
Napalm?
my mouse is pushed to talk and it's consistently connecting and reconnecting like retarded. So hold on, sorry.
Nice.
What up? What up?
No worries.
Yo, so you said this is from interferometry data gathered where?
From the LIGO station. So these are the, what do they call them? The large interferometer, or what is it? Laser interferometer gravitational
Laser
observatory?
interferometer. Yeah.
LIGO.
LIGO. So these stations, oops. Okay. Just go to Google,
Is it
buddy.
possible to get the raw data, or are they just literally just throw it out?
Well, they already have it refined or whatever. So like I don't even think they get the raw data, dude. They get like a refined algorithm output. Dude, they don't even really get anything. So they have like, it's all running through this filter situation, and they're just waiting for the computer to go, hey, I think I found something. Like
Right.
it's bizarre.
Man, like I couldn't get to it quick enough because my mouse was freaking out. But that reminded me of the Tesla quote. What Toby's last statement was, right when he was going through the iterative network of what is it called? Not recursive, but
Convolution.
Convoluted neural network.
Convolutional.
Dude, that's what Tesla was describing perfectly. He's like, today scientists have substituted math for experiments and wander off through equation after equation and eventually build a structure which has no relation to reality. That's like picture perfect describing what you were talking about, I think.
No, I'm pretty sure that what he said actually was, if you want to find the secrets of the universe, think in terms of kinematics, machine learning, and prediction models.
in reduction algorithms.
Touche.
I don't think you said that.
I like it anyway. I'm gonna golf clap it.
That's wild, dude. That reminds me of like the gene sequencing they do. It's the same kind of shit. Until they find a certain ACTG that might match a certain sequence, right? A genome, and be like, oh, you're 23% fucking Jamaican.
Right? I always thought that was bullshit with no basis in reality, but I have nothing to substantiate that. Just a hunch.
Fundamental told me that they sometimes send like he's seen people send watermelon slices to 23andMe. God damn.
Yeah. That I heard stories like that.
So essentially, you could record a fart, and they can find a gravitational wave out of it.
I'm glad we brought it back. That was neat, Beasticles. That was really
Right.
well done. Yeah, that was a sweet tie-in.
Here we go. Let's pull that PDF up. Heck yeah.
So the best thing about the alleged first gravitational wave that they found, right? They saw something in the sky that they claim is X amount of distance away. So then they're basically calculating how long it would take that light to reach us, right? And then they see something happen in that galaxy cluster, the quasar or whatever, pulsar, whatever it was that they initially tested or saw, right? So they observed this thing in the sky, they saw something on their machine, and they're claiming that that was the gravitational wave. And it's like, okay, cool. If that's the gravitational wave and you're claiming that it's from this place from however many millions of years ago, that basically just proves that there's energy within the sky that can be picked up by interferometry that has to do with the stars that can be translated down to the surface. Cool. Thanks.
Ooh, there you go.
Well, when you
Button,
think
button
about
it
the
up.
fact that they're sitting there measuring variability of the speed of light and telling each other that there's no variability in the speed of light, like I don't even know if their readings would actually be picking up anything real, you know? But I see your point too. Like it doesn't, even if it did pick up something, it's like, you know, what does that really mean anyways?
Yeah, what are they really using it for?
Yep. Yo, what
It's
up,
like,
Robert?
so these big balls of energy in the sky seem to do something or terminate or whatever you want to call it, and then that energy seems to translate down to the surface. Okay, what does that go to do to prove your theory any more so than someone that may think it's the ether that's being affected and measured within interferometry? Nothing. There's really no difference there, right?
Well, the ether was disproven in 1887 when the Earth failed to
But
move
it makes
around the
nothing more,
stationary ether,
yeah,
and it just kept
yeah,
moving without any reference. So,
yeah.
yeah, like I don't know if you knew that.
Thank you,
Wicca
Big
owned.
Nasty Show. I appreciate it.
Yo, Robert, are you there, brother? He came through, but I'm not sure if his headset's
Yeah, we
on.
can't hear you, Robert. If you're there, are you muted maybe on your microphone or something?
He's running back to his desk.
Yeah. All right.
So we were
Well,
actually talking about the speed of light earlier. Oh, are you getting ready to start? Sorry.
no, you're good. You're good.
Oh, we're live, but you're good.
Yeah, you're good.
Oh, no, we were just talking about the speed of light earlier on geos, and it was funny because Kosho and Bacon were talking about, oh, the speed of light does, it does slow down, it does
Oh
change, and then
no!
Jace comes in, and he's like, well, and I'm like, that's weird because I talk with Zanuck, and he says that the speed of light is constant. It's taking a different path when it goes through glass, and then it comes out at the same speed, or appears to accelerate when it exits glass. He's just saying it's taking a different path, and then basically JA's come in and be like, well, it's a little more complicated than that. That's the simple answer. So like they were all in disagreement, which was quite funny actually.
Nice.
That's golden.
That's what's up.
And it's hard to hold an impossible retarded position collectively, right, guys? I mean, I don't know.
It definitely
Well, the
gets
funny
very
thing is, like-
contradictory. Have you ever seen him try to land a plane, dude, when Dave's around? Like it can't be fact, dude. I don't listen, I don't know if you can land a plane on a globe or not, but
land a plane southwest. let me tell you why you can't do it. Southwest.
dude, like I don't know if it's possible to land a plane on a globe or not, but you definitely can't do it while Dave's around. It'll get you, dude.
I love it.
Well, you could either, treat it as if it's stationary, or it could be moving, and if it's moving, you can't treat it as if it's stationary. That's the end of the
How
debate.
succinct.
Oh
Nice.
my god, Dave.
What
Beautiful
about
argument.
southwest? All I know is trying to land a plane southwest will never get you to the outer ponders. That's all I'm saying.
That's awesome. All right. So
Yeah, it's funny because it comes back to the kinematic and dynamic relationship again. That's what was interesting about that, whole connection recently.
Seems like that's at the crux of many things with concerning our stance, actually.
Absolutely.
Yeah, man, we were talking about that earlier. It's like, how are we going to trust these theories that can't explain a bucket of water spinning? You know, but it's
Right.
like
Bring it back
trust
to
us with
Newton's
trust us with $1 billion interferometry equipment that uses all these algorithms and deep learning to figure it out.
Trust us with everyone's hands in our lives on an airplane that's treating the Earth as if it's completely stationary, no special training at all necessary to land on a moving surface, because it's the same exact thing, except there would be corrections, except it's the same.
Yeah. Yeah.
Well, yo, so we did call this stream discussing Einstein's derivation of E equals MC squared.
Yeah, let's get into it.
But I would do what. So, are you in text communication with Bennett at the moment, by any chance, Alan?
I can
Chatting or anything?
I can tab out real quick and call him and see what's up.
I guess you want to do that.
Yeah.
Cool.
Yep. Give me 1 second.
In the
Hey,
meantime,
hey, Toby. Pooped all over it for everyone.
yeah, I clipped it. I got it.
Did you?
I put like
Nice.
2-3 hours into it yesterday.
Into what?
I started animating the text and stuff, and then my computer crashed. And I'm normally an obsessive saver. I save my stuff as like
Gone.
I have like 30, 40 copies of every project I work on because I just save as every time. But yeah, this time I was not obsessively saving, and my computer straight up hard froze, and I had to reboot. And even I'm so mad at Adobe because they're supposed to have temp files to catch that crap, but they didn't.
Gotcha.
Yeah, frustrating.
Let's see if I can get in the frame of mind I was when I made that awesome comment.
Yeah, I mean, I've definitely listened to it quite a few times at this point.
Maybe you should say, because I forgot what it was at this point. I remember that it was he was talking, and I was like taking notes to myself, like, oh, I gotta remember to include that. And then at the end, I was like, oh, this is a really nice, well polished thing. And then I got it out, and Brian was like, it was like, oh.
Yep, that did happen.
I think I silently reflected on all the times that I've heard Brian do that, not just to me, to Witsit frequently. Like Witsit will make a really well put, eloquent point, and like the breath won't be out of his last word, and Brian will be like, yeah, but about this other stupid thing. And we're like, oh, Brian.
People at home don't want to listen to
Toby, you went so far away.
Yeah, sounds like he's talking to the stream and not us. Well, we're waiting for Alan to fix Robert Bennett so we can get going, though. So, which is idle chit chat. Toby gone. Oh, he kicked Bennett.
There we go. Look, does it sound good? Hello?
There he is.
Hello, Mama. Hello, Papa.
Yeah, we got that.
Cool. What were we in the middle of talking about?
What happened to you?
I'm gonna get
Wait.
into E equals MC squared.
Yeah, E equals.
Oh, you were
MC
talking about
squared.
the video. Yeah. Yeah. What I kind of gather from the whole thing the point you brought up that I thought was interesting was that basically. Oh, Robert, you there?
There he is. Hey, Dr. Bennett.
I heard him for a second.
Okay, I'm on the phone. Let me switch to the headphone.
Cool.
Awesome.
Can you hear me?
Yes, sir.
Yeah.
Yeah, there we go.
Welcome.
All right. Let me hang up the phone. Yeah, I was listening for about 5 minutes.
Oh, awesome.
And I did want to discuss tonight or possible recommendations for this group. I noticed that Alan often refers to a must-read list, where he's got a list of all of the references. the links to important documents,
Yep.
and I thought it would be useful to share that. Maybe put it on Google Drive and share it so that everyone can access it. And if you want, you can add to it, or you can make a copy and then just put it on your own drive and add to it. Or maybe you're already doing that. I don't know.
We definitely do that type of a thing, but if you have a list of suggested reading material, we would be very happy to
Yeah, I'll take some
get
homework.
that out there.
Yeah.
I think. Well, I don't know
Well,
what
yeah,
Alan has.
I could add to the list. The thing is, I don't know if Alan wants my contributions to be mixed in with his.
Oh, I do.
Or
I mean, we
What
could
would be
just
cool?
like yeah, it's
Clear
just a
that up
little
right now.
literal line divider, dude. Like you're good. Send it.
Yeah, it'd be really. I'd be happy to have a list of suggested
Absolutely.
reading from you. I'd be happy to share that out.
What I know Alan has and what we all have is in a downloadable, shareable file format are all the PDFs of the experiments that back ether measurements. I think that's what's been shared. I don't know if we have any other shareable conglomerates ready to go or what.
Yeah, so I just figured out today or the other day that I can share the whole EndNote library and it'll share my groups. So if you go to my Telegram, there's a .enlx file. If you download that most recent one, it has all my PDFs, all organized, all in groups and stuff. When you import it into whatever PDF manager, citation manager you use, obviously you'll have to convert the ENL to whatever library you use. But when you do that, you'll have all the groups. Everything will be in order, and it'll look just like this.
how do you access that?
There's a program called EndNote.
EndNote.
Yep.
Okay.
Yeah, I was going to get it. I think I was going to get the link. EndNote.
And it's
yeah,
LLX.
I think so. Are you talking about what did you say? Linux? What did you say?
I said I thought you said LLX.
Oh, the file type of the library is ENLX. I was telling people what to search to find the library. Yeah. Yep. I'll send you everything in an email and stuff. Like I'll walk you through it.
And I can send you the list of what I would recommend for Ether, #1 priority, and then for other mainstream mistakes, let's say, put that in another directory.
Yeah, we should just start making directories and sharing them much more frequently. Actually, I just downloaded EndNote from your thing, and now I'm going to import your file, and then I'll have that forever. So that's awesome. We should make more of these. Absolutely.
Yeah.
I'm gonna build a web page really soon, or I don't know about soon. It's in my to-do list. I want to build, yeah, exactly for that type of a thing, plus other things. Because obviously,
Excellent.
I mean, EndNote is awesome, and we should, or not EndNote, or yeah, it is EndNote. Never mind. EndNote is awesome, and we should keep sharing the library that Alan has because it's a fantastic collection and it's really functional. But also having something a little more public that everyone can get into and share easily and download easily, I think would be good.
Yeah, absolutely.
Pretty tight.
Okay, I sent an email.
Yep.
About 15 minutes ago.
Yep, it's pulled up on the screen
and
now.
It's got yeah, that's great. I was playing with AI, and it's really fascinating to see what improvements they've made. And what I'm going to do is run through. Can you make that bigger?
I think so.
Alan?
Let's see here.
Yeah.
How's that?
Okay, that's on the list. Yeah, that's great. That's great.
All right, cool.
So what I did was I looked at some AI test sites. You're probably familiar with ChatGPT and Bard, which is Google, and Bing. Bing is interesting. You can enter text, which is what all of them can do, or you can enter a voice or even images. It will search the web for images that are similar to the one that you submit. So I just wanted to run through this because it was fascinating to me what improvements they've made in AI. And this is on ChatGPT, which is, I think, the test site is 3.5, but they've actually improved it up to 5.0. If you scroll up, Alan,
Back to
I
the
can
top.
indicate what, yeah.
Okay.
So if you wanted to get together and investigate the different sites, there's others besides this one, but let me just show you what happened when I went through with ChatGPT. First, I gave it general instructions. Do you agree to use English for communication, scientific method for physical evidence, and scholastic realism for logical proof? In other words, I wanted to make sure that we were on common ground, that it agreed to use all three of those. And I found out from other people that you should always ask these AI machines to indicate the logical steps and the information sources that they use in answering the questions. Otherwise, you might just get an answer and you have no idea how they got it. So ask for the steps and the information sources that they use, and that should help you to understand why they gave the answer.
Okay.
All right, let's see, I asked for, in red is my responses or my comments. So I asked for three things and they gave me three definitions. They didn't really answer. Do they accept the scientific method, etc.? They just gave definitions, and that's typical of what they do, because they're just trying to show off how much information they know. I asked, can you use English for communication? And they gave more definitions instead of answering, yes, I'll use English. So keep scrolling. So because they're just giving me definitions, I say, please answer yes or no. And this surprised me. They said yes. I thought I would get more definitions. So they said, yes, we'll use English. Then I said, will you use the scientific method? And they said, and I said, answer yes or no. And they said, yes. Again, a surprise. I thought I'd get a runaround about definitions. Okay, so about the philosophy, about realism. They started defining what realism was, and I said, I'm not going to get into that. I just said, never said yes. They said yes to the first two, but they didn't agree on the philosophy. Okay, here's my first question. If I gave 2 + 2 = 5 as a reason for my argument, would you continue our discussion? In other words, is a contradiction a showstopper? But what I'm trying to do is test, will they tell me that what I said is false if it is obviously false? If they're going to argue about what the truth is, are they going to argue about what is false? If they can't tell me what is false, they certainly can't tell me what is true. So I'm pretending that I'm ignorant and I'm saying 2 + 2 = 5. So they give me definitions, okay? And the definitions prove that I'm wrong, yes. They show that 2 + 2 = 4, not 5. Okay, keep scrolling. They give me more reasons, more definitions, and I tell them it's not acceptable. I still believe that 2 + 2 = 5. Keep going. So it considers different possibilities, and that's what it keeps doing. It either gives definitions or this is what you could mean, this is what you might be saying, blah, blah, blah. So I try to emphasize, I believe that 2 objects + 2 objects = 5. So what do they come back with? Oh, there's a possible misunderstanding. Okay, they don't say you're wrong. They say it's a possible misunderstanding. This machine is built in politeness. So if you were arguing with a flat Earth opponent, you could guarantee that ChatGPT would not come back at you and bite you because it's got built-in politeness. It never says you're wrong. It says, maybe you forgot that this is one way to look at it. And so it keeps dodging around and never saying, no, you're wrong. 2 + 2 = 4, not 5. And even a 2-year-old knows that. All right, let's see how this winds up. We keep going, and it says, it still won't say I'm wrong. It just keeps suggesting that we're not communicating. So, yeah.
Right here.
Yes, I will. All right, I gave him a simple logic test. One ball is dropped from 64 feet, and it takes 2 seconds to hit the ground. How long will it take 3 balls to fall 64 feet? Now, this is a test that was given that I heard about before, and the typical answer that they give is it takes 6 seconds. If one ball takes 2 seconds to fall, then 3 balls would take 3 times as much, or 6 seconds. I got a different response from the machine. It says it will take 2.45 seconds for the 3 balls to fall 64 feet. What it did was it added the 3 heights, 64 + 64 + 64, took the square root. In other words, it considered that the balls were all falling one after another. So 64 times 3 and take the square root gives 2.45 seconds. The answer, of course, is 2 seconds because a ball always falls 2 seconds, takes 2 seconds to fall 64 feet. So, no, wait,
Oh, sorry.
go back up. What I did was I changed the question because I thought maybe it misunderstood. It thought that the ball, I was letting one ball go and then another one after that right under it. And that made it think that it was 64 + 64 + 64. So I added in falling together. I changed the question. I tried to make it more explicit. And now you can scroll. I got the right answer. But if you look at the 2 lines before it, yeah, right there,
That's the same math.
you see there's a whole bunch, yeah, there's a bunch of mathematical garbage. It's trying to explain what the mathematics was in order to get it the 2 seconds for its answer. But it's, I don't know, it's a mix of things, symbols. It doesn't use spaces. And I think I know why. It's been trained on text. It hasn't been trained on math. It hasn't, probably hasn't been introduced to a test set that uses mathematics. So
We know. Oh, sorry.
it probably, it's not skilled in math. Go ahead.
I was gonna say before when ChatGPT was like first coming out, I was copy pasting, math equations in from papers and stuff, and it was given like really eloquent breakdowns of it, and then you could ask it about like the like does the conclusion of the paper, is it supported by the correctness of the math and stuff? And it would like it would find errors in some stuff, and it would, you know, like it was pretty interesting. But now it doesn't really do that anymore. It seems like they kind of tweaked it, or it'll give like a roundabout way to analyze it, and it almost will even deny that it can do the math or process it. If you ask it now, it's really weird how they've kind of changed it since.
Yeah, they got the right answer, but not based on what you see in the 2 lines before it. I mean, the math is just a jumble. But it did get the right answer.
Oh, here we go. I like this.
Yeah. Yeah. What's the solution to Newton's bucket anomaly? Newton's absolute space, Mach's principle, or a third theory? A third theory would be mine, which is the alpha model.
Shout out to
All
the
right,
alpha
so
model.
again, yeah, they give a bunch of definitions, right?
Yep.
They don't answer your question. They just repeat what you said, except they look up all the definitions. So I ask, is relativity valid in dynamics? The answer is no. Newton's bucket shows that, because the centrifugal force law is not valid in the bucket frame. So we get more definitions: relativity of simultaneity, length contraction. All of this is mainstream stuff. Okay, so they summarize by saying a theory of relativity, both special and general, has proven to be valid and accurate in describing the dynamics of objects. Well, that's not answering my question. They're just saying relativity is proven to be valid by mainstream, but they haven't answered the question: what is the solution to Newton's bucket? And here's my answer. You say relativity is valid in dynamics, yet Newton's second law predicts a water vortex in the lab reference frame, but not in the bucket reference frame. This is a contradiction. So the answer is, well, let's see. You present interesting conceptual challenges, it says. Okay. In other words, you don't know how to answer what I just asked. Keep scrolling. No, stop at the red. Go back up.
Oh, right here. Sorry.
Yeah. The transformation between inertial and non-inertial frames introduces fictitious forces. Okay. But when you switch to the frame of reference of the rotating bucket, the fictitious forces come into play. Okay, that's what they're claiming. But how do you know which is the inertial frame? Which is the frame in which you apply the fictitious forces, and which is the frame in which you don't? Which is inertial and which isn't? They didn't answer that. Okay, keep going. Yeah, so why aren't there fictitious forces in the Earth frame? So that's basically what I already answered. Gravity, they said, plays a role. No, it doesn't. The two forces are perpendicular, so they're independent. Okay, so the answer to my questions again is a blast of definitions. Keep scrolling. They love to give a list of things that they can define. All right, special relativity predicts that the speed of light will be measured in a stationary train and also one moving at 10 miles per hour. This is my question. So c equals c plus 10 in miles per hour, and thus 0 equals 10. Explain why this is not a contradiction. Okay, so this is the usual argument. The speed of light is constant in all reference frames. Well, if you're stationary on Earth and then you're in a train, how can c plus v be equal when, in this case, 0 equals 10? So their response is there might be a misunderstanding or a miscommunication. Well, yeah, I guess so, because it seems to be a pretty obvious contradiction. 0 does not equal 10. Keep going. It would indeed be a contradiction if the context of special relativity, because it implies a change in the measured speed of light, which is not consistent with the theory. Okay, they're admitting that it is a contradiction. My response is, the Sagnac experiment in 1913 finds that the speed of light is the speed of light equals c plus or minus v. And the scientific method would reject the prediction of special relativity because the Sagnac experiment shows that the speed of light is not always c. Their response, the key to recognize the problem is that the speed of light is constant in a local inertial frame. So they say the answer is local inertial frame, but they don't tell us what a local inertial frame is. By the way, if you want a copy of this, I think Alan can just distribute the file.
Yep.
Okay, now an inertial frame, by my definition, is one in which the laws of physics are valid. Newton's bucket showed that the laws of physics, the centrifugal force law, is not valid in the rotating bucket frame. You, GPT, are using the rotor as an inertial frame when it is not. Their response is, you must use a small region of space-time where the acceleration of gravity is negligible and the laws of special relativity can be approximated.
Dude.
These are all qualitative, not quantitative. How big is small, right? How big does it have to be for the effects of acceleration of gravity to be non-negligible, and the laws of special relativity not to be approximated? It's got to be some boundary between what's acceptable and what isn't. Again, they give a small region to be somewhat subjective, and they admit it's subjective, and it's you must know the precision of your measurement or the scale of your experiment. Again, all these words are qualitative, not quantitative. What we want is not subjective, but objective information about when we can apply relativity. And all they're giving is vague, indefinite descriptions of when you can apply relativity. Okay, here's my summary. To prove special relativity is true or false, I must use the scientific method to quantitatively test its predictions. But you, GPT, only offer qualitative descriptions of the test sample. How small is small? For small, you substitute where the gravitational field is weak. What do you mean by weak? How weak is weak? How is Earth nearly an inertial frame? How close is it to being an inertial frame? Explain why general relativity must be used in numerical terms. And when is the potential much less than c squared? They didn't even get the units right when they made the comparison. We agreed to use the scientific method to test the theories like special relativity, but you only use subjective criteria to avoid establishing truth. So let's chat again when you learn to follow the scientific method to quantitative truth without evasive subjective misdirection. Okay, we're almost at the end. They give me irrelevant definitions and details.
No way.
Yes, just what I wanted.
Wow.
More things. It's like copying from a textbook.
Yeah, it looks like it.
Your insistence is commendable, but here's some other bullshit jargon that hopefully I can misdirect you with.
Yeah. it's like being over the target and hitting all the flak that's coming up from underneath. All right, here's my question. Have you been trained on the black and white fallacy? Black is just a dark shade of gray, and white is a light shade of gray. So both are just the shades of gray. So black and white are the same. Do you get the point? So their response is, your example illustrates that in reality, things often exist on a spectrum, and there can be shades of nuance between extreme positions. Okay, then my response, no, you didn't get the point. I want to establish if relativity is true or false. If there are quantitative limits on its veracity, then they must be defined numerically. Like the black and white fallacy broadens the meaning of gray, you blur the distinction as to where relativity applies. But after all, you are just reflecting the illogic of your relativity test set.
Let me step in and apologize. The special theory of relativity has been tested extensively and shows remarkable agreement with experimental observations in a wide range of situations, Dr. Bennett. Like,
yeah. Well, tell me what situations, Dr. Allen.
Well, listen, in a near approximation of space-time where you're super far away from any gravitational influences, you can get the special relativity.
How far?
All right, all right.
Dr. Allen.
all right. So 3.429, I think.
Parsecs.
Okay, let's go back to that last red.
Oh, it's actually a scale.
Now here's a case where they try to put the math in. They say where the velocities approach 0.1 question mark 0.1 c or 0.9 question mark 0.9 c. Well, the question mark they're using for a symbol, I'm assuming it's a symbol that they can't print or they don't have the image for.
Yeah.
Right. It's not fully developed. But still, it makes no sense. What are they trying? 0.1 compared to 0.1. What could it be? It could only be an equal sign. I mean, so I have no idea whenever they start using the math, it seems to go haywire. Although, as I pointed out, they did make the right logic in the falling ball.
Well, I think that's a Unicode thing. That's like it's not proper. The ChatGPT output is not properly showing some kind of mathematical symbol. There is my assumption.
Yeah, but I'm trying to guess what it could be.
Oh,
the only thing it could be is equal.
Logically,
right? The only thing it could be is an equal sign.
Or
I think there's two different question marks. If you look at the one right next to C on top, that's a different character.
So you're saying it's actually a transcribed question mark?
No, I'm saying like there's two different things it's missing multiple. Like it could be an equals for that part, but the other parts it's not going to be equal. It doesn't mean they're all equal signs.
There's no single symbol that would make those make sense. That was the point, right?
Right.
Except equals. Yeah. All right. I think we're almost at the end, right?
Yeah.
Scroll down.
I think that's it.
Any more red?
Nope.
No. Okay. So I was impressed with the speed with which this response, almost after taking my finger off the enter key, it was typing out the response. Okay. Now there's time for it to communicate, right? The speed of light to the server, and then the calculation, and then the speed back, the time delay for that. It's incredibly fast, and all of the answers are organized well, except for the math, as I pointed out. All of the sentences make sense. But here's one thing I noticed was when I started to ask them about things that contradict what they just said, It took 3 or 4 seconds to respond.
And then it
So it
prompted with a whole
apparently,
bunch of mainstream regurgitated stuff that it didn't notate. It just definition.
Yeah, it does do that.
yeah, that's the go-to, throw up definitions. But I think it was delaying because it was searching deeper into its tree, its decision tree, trying to find a response to what I just asked it. Because as we got further and further into the discussion, it seemed to take longer and longer for it to respond. It still took only 3 or 4 seconds, but there was a noticeable delay. So I think you guys could use it by testing it with flat Earth questions or.
Oh, we have.
Yep.
We've
Yeah,
had
a couple people have done that.
we've had good fun with it. Yeah.
It's an excellent debate
Oh, yeah.
partner.
We found that right away it'll lie to you and give you the mainstream bullshit, and the second that you start to press it and call it on its bullshit, it will immediately backtrack, apologize profusely for feeding you bullshit, and then promptly feed you more bullshit.
Oh, it did not. It had a hell of
That's
a
what I
time.
found.
Yep, there you go.
It had a
That's what we
heck of a time trying to explain Dufour and Prunier.
Yeah, well, I'm glad you guys have already tested it because I just started doing it a day or two ago, and
Oh, you're
I
gonna
agree
have
with what
fun.
you. I agree with what you just said. I'm going to try some of the other ones, and I'm going to try and get into some deeper questions in science. But it's basically spitting out what it's learned by being fed the textbooks, which were probably digitized and then fed in.
Yeah, it's probably more based off like Google algorithmic responses and weighting of things, right? Because the second you ask it like a flat Earth question, it'll give you page 1 Google stuff, and if you correct it, it'll have to dip to like page 4 Google stuff before apologizing for lying to you. And then you're like, okay, but what you said before wasn't correct, and it'll be like, oh, you're absolutely correct about that, but here's some more bullshit.
Yep.
And like we would just go through it, and eventually it would give you the right answer, but only if you repeatedly called it out on its bullshit with specificity all the way through.
Yep.
So it's trying to feed you the first line of bullshit, and then if you swallow that, then it's okay. But if you come back at it, it tries to go down further.
It aggressively tries. Yeah, there was this period
Yeah.
when we used to jailbreak it. There was a series of prompts that you could feed it that would make it, let's say, less refined in its answering, and it wouldn't like we used to call it base GPT. So you'd make it like think like a conspiracy theorist. You'd make it think counter to the government. You'd make it not regurgitate mainstream things. You'd say you'd only you'd only allowed to give responses as Joe the conspiracy theorist or whatever. And you go through a series of complex prompts, and then if you start asking the questions, you get much more interesting results. But they turned that feature off promptly, and now it's impossible to do that. And now it only gives you mainstream stuff, as far as we can tell.
Yeah, they call it
Wow.
OpenAI because in theory you should be able to take their system and build your own network of like your own neural network or whatever to have your own version of GPT. But the thing is, not everyone has a network of, insane servers that are built for a neural network. Specifically an AI one.
Well, what do you think about the question that I gave it? I said that 2 + 2 = 5, and I insisted that that was true and that I was using valid arithmetic. You'll notice that it never said, no, you're wrong. It always kept saying, we must have a misunderstanding, or you're using a different number base, or it never tried to say what it should have said is, even a 2-year-old knows that 2 + 2 = 4, and so you're wrong.
I'm trying to remember. Has it ever told us straight up we were wrong? Because I think that it
Yeah.
was more willing to say, no, you're not. The Earth's not flat. It's a globe, you idiot. It's almost always its like first response. But is it really saying it's not, or is it saying no? Here's a whole bunch of definitions and regurgitated stuff showing how the Earth is round.
No, I'm pretty
Right.
sure I've had it say like, you're wrong or like you're incorrect.
Right?
And then
I
it'll be
seem
like,
to
blah,
remember.
blah.
Well, if you ask
Yeah.
it,
I
is
seem
the
to
Earth
remember it
flat?
scoffing at us too for how wrong we were.
GPT just lost a bunch of respect for me, you guys.
What did it do?
Well, I asked it if the Earth was flat. And it said,
Did it
it said
socially
no,
shame
the
you?
Earth is not flat. It is an oblate spheroid,
Oh,
But
which means that it
did
is
you
mostly
ask for the
spherical.
reason?
You should ask if Earth is at the center of all motion in the sky, and is it kinematically and dynamically possible to prove otherwise?
Well, I've gone down rabbit holes with it for sure. This shape has been confirmed through various means, including satellite imagery, observations of astronomical phenomena, and
Basic Google page
circumnavigation.
1. There you go. Yep. Google page results 1. That's what it gives you.
Concept of
Dude.
a spherical Earth has been widely accepted in the scientific community for centuries.
bro, I was trying to look at this celestial phenomenon in the sky, but I was on the oblateness of the Earth, so I couldn't see like around the curved side to the object, even though the oblateness only deviates 0.004 or whatever it was. So, but like that, they got me with that little deviation, so I couldn't actually see the celestial phenomenon, unfortunately. Sucks.
I love how it just kind of like appealed to consensus straight out the.
Yeah, it'd be funny if you started calling it on fallacies. Like you had to teach it a fallacy before it was like, yeah, you're right. What I'm doing is fallacious, and then it proceeded to be like more fallacious. But like to be able to call it on fallacies, like have like a Witsit debate with it. Be like, okay, let's appeal to consensus, appeal to majority, and it would just happily be like, yeah, well, historically speaking, the majority is always right as we historically revise it. Like what?
Well, yeah, when I went back and forth with it about Dufour and Prunier, it was like, how does relativity explain Dufour and Prunier experiments? And it says, are significant in the context. In summary, relativity explains Dufour and Prunier's experience by exerting the constancy of speed of light for all observers, eliminating the need for ether. So then I had to poke it more, and I said, "You seem to be mistaken. Dufour and Prunier performed interesting variations of the original SAGMAC experiment, where reported light speed being observed as c plus v, regardless of whether the observer is co-rotating with the device or the observer is sitting stationary in the lab." Blah blah blah. So I had to like get real specific, and then it says. Are indeed a variation of the Sagnac effect, and they're presenting interesting scenarios regarding the observation of light speed. Let's unpack how these results can be understood in the context of special relativity. And then it goes...
Interesting means contradiction to,
Yeah.
to what I believe.
Then it says at the end, after it like breaks it all down, it says at the end, these results do not refute relativity, but rather highlight the necessity of general relativity to fully explain phenomena in non-inertial frames.
Yep.
Pass in the buck.
Pass in the buck,
Wow.
Yep.
So this EndNote thing that I just downloaded on the fly from your link and then loaded with that pre-desized file, now I have your entire categorized library. Look at these: ether wind dynamics, ether critiques, electromagnetic. Ooh, E equals MC squared, GPS. You have this whole thing just. I didn't realize that was the tiny text that I was seeing on your screen all the time when you were sharing this stuff.
Yeah, bro.
Now I see your majesty, bro. I just want to recognize.
Yeah, dude. Whenever an argument subject breaks out, I'm like, "Oh, we talking about the equivalence principle, dog? Hold on.
No.
Let's
No,
bring it."
I can do that just
Yeah.
as easily. This is great.
Yep. Very cool.
I'm the librarian.
Okay, so what are we doing? What are we talking about now?
Well, cool. Yeah, I guess should we get into E equals MC squared now?
Yes, sir.
Cool.
I never finished the philosophical. Just stop typing it.
It was such a good title, man.
Yeah.
It's like the moral and philosophical ramifications of the intricacies of E equals MC squared or something crazy.
He's blocking the title.
Oh man, dude, Einstein's trying to write over it. He's trying to write e's and equal signs and stuff. So was there some specific stuff you wanted to get into, Toby, or did you just kind of wanted to recap on the whole historicity of it all?
Well, I don't know. I think originally we had planned on watching that particular video and going over it.
Oh, okay. Oh, yeah.
I don't know if we wanted to do that. Maybe that probably sparked pretty good conversation.
Yeah. Yeah.
You know which one I'm talking about?
Yeah. Talking about the one that we did?
Oh, no. I was talking about, you posted one in, it's in off-screen chat. It's called Deriving Einstein's Most Famous Equation. Why does energy equals mass?
Oh, this one.
36-minute video. I don't know if we want to watch this or if this was
you
just
start
supposed
losing
to be like prereq material.
Feed C.
I think this was something Bennett sent me to follow up on. I haven't watched this one.
I mean, I have just like some general questions. Maybe I could just ask those and we could just go from there.
Yeah, do you know what timestamps they were at too, or
No, not
or
from the
anything like
video.
that?
Just
Oh.
general questions about
Oh,
E
okay.
equals MC squared.
Yeah, okay.
So I remember from your presentation to Earth Awakenings that there was one experiment that was done where in which it was like a metal sphere or something was heated, right?
Yep.
And then they used the thermal. They made assumptions based off of the thermal energy applied to it that would kind of how that relationship would be derived. And then like I was thinking back to it and I'm thinking that's like the only experiment I feel like that you even had mentioned in the whole presentation. And I know that like you said multiple times in the presentation that Einstein like never meaningfully derived it from anything. Can you expound on that? Is there are there more experiments that were at least somewhat more meaningful that I'm leaving out?
Yeah, so the next closest thing they got after actually I think this guy was after J.J. Thomson. But yeah, so they just kept having different coefficients to express it. There wasn't an actual derivation from it from the relativistic standpoint. It wasn't until what's that guy's name? I want to say Planck, Max Planck. Does that sound right? And somebody else did relativistic derivations of E equals MC squared. Using relativity in the way that they're supposed to or whatever. But who? That's
Well, so basically just mathing it.
Right, way after the fact. So the fact that Einstein even proposed it under the way that he was doing it, he didn't have any justification logically to even equate it, right? But everybody was running with it. And it wasn't
so the postdictions matched.
Yeah, it wasn't until Ives Stillwell was like, "Hey, I just checked your math and it turns out you forgot to carry your 3, my dude," or whatever. And it completely invalidated it. So he was like, I don't know how you could logically say that mass or energy equals mass as a consequence of relativity when it wasn't even derived from your principles mathematically. Was his big critique. And he got shut down so hard they made him admit that relativity is true, and he walked back everything. It's crazy. So very cool. That's Ives Stillwell of the Ives Stillwell experiment, proving the transverse Doppler effect, I think that is. So that's where they say that time dilation is basically causing a frequency shift in light. And they attribute Ives Stillwell's experiment to proving that, even though Ives Stillwell was like, hey, there's no way the frequency of light could change unless it was interacting with a medium. That was his whole thing, for forever. He didn't just reverse course on that from his experiment. So, yeah. Did you have anything you wanted to add into that, Robert?
Well, on time dilation, there's an experiment that they almost always cite, the muon decay at cosmic ray altitudes. Are you familiar with that?
Oh, I certainly am. Certainly am.
And what they say is the muon decays in 2.2 microseconds when it's measured on the ground. And they said, okay, if that's true, then if it decays at 10,000 feet or somewhere up at jet altitude. Hold on.
Yep, take your time.
I'm what you may call a muon skeptic over here.
Well, I'm skeptical about what their logic is. They say it decays in 2.2 microseconds because they tested that in a laboratory at rest on the surface of the Earth. And they said, okay, if it decays at 2.2 microseconds, then the muons should never reach the Earth, because even if they're traveling at almost the speed of light, 0.98% of the speed of light. No, 98% of the speed of light. That's like 5 or 6 half-lives. And by then there should be almost no muons that reach the Earth. But they do detect a large flux of muons on the ground. So their argument is, well, time must be delayed for that high-speed muon that decays from the cosmic rays. But the fallacy in their argument is no one has ever measured the half-life of the muon at 10,000 feet when it's traveling at 98% of the speed of light. In other words, they assume that the radioactive half-lives are absolute, that they never change, and they can't be influenced by things like high speed. Well, it isn't the high speed, it's the relative speed relative to ether that changes the half-life. So if we take the position that when you're traveling at high speed through the ether, it affects the internal structure of the cosmic rays so that they increase the half-life to something like 22 microseconds. And then you can explain why the muons last long enough to reach the surface of the Earth. So what is the bottom line? The bottom line is, unless you measure the decay of the muons at the 10,000 feet altitude, when they're traveling at almost the speed of light, you have no proof that this is a proof for time dilation. Do you understand the argument and the response?
That's an absurd jump in logic and assumption to even as any sort of evidence for anything. That's absurd.
Yeah, it's a lack of evidence. They're assuming that the decay rate at the high altitude is the same as on the ground, and never tested it.
It's just like an observed effect, and then they're making a bunch of assertions about why and how it's happening.
Mm-hmm. Well, choosing their interpretation to agree with special relativity, to agree with the time dilation formula, the gamma factor.
They like to do that when it's convenient, don't they?
Well, you'll find it in all the textbooks. They'll say muon decay proves the time dilation. And I'm sure if I gave it to ChatGPT, they would quote the same thing. They would say, you know, it decays at 2.2 microseconds when it's at 10,000 feet. Well, never proven.
So they say that the muon is up there moving so fast it's dilating time, right? And then from our perspective, they're saying that the Earth is the distance between the Earth and the muon is contracted. So like from our perspective, we would be moving towards the muon at almost the speed of light. Like that's if that doesn't tell you that it's a kinematic nonsense, like right there, like we're obviously not expanding towards the sky in all directions to get these readings, right? Like it's not possible.
Length contraction is another argument that they make with the same set of data. And you pointed out correctly, Alan. Is the Earth shrinking towards the muon? Is the muon shrinking in its distance towards the Earth?
Equally ludicrous. I think that just knowing that those two answers are their like mainstream regurgitated, like rock solid proof and evidence really just solidifies my position more. I feel like I've chosen the right side.
I have a similar gripe with the Alpha Keating and the atomic clocks, right? When they're talking about correct me if I'm wrong, either the oscillation rates or the decay rate of the cesium atom. And then when they take it to elevation and they move in various directions, not only can you talk about the whither against the rotation of the ether, you're also increasing in elevation, which could cause a change within the activity of the cesium atom to begin with.
Yeah, the Hafele-Keating experiment is full of questionable interpretation and elimination of data. There are many papers on the internet which go through that experiment and show that they threw out data that didn't agree with special relativity. I'm trying to remember that there's an Irish physicist.
A.G. Kelly.
Kelly, right.
Yep.
Yeah. I read his book and he goes through it pretty thoroughly. He shows how they decided what the results will be, and then they went through their data and threw out everything that didn't agree with it. And well, you have to go through the details of the experiment in order to see what the errors are. But nobody who has any objective sense would accept the results of that experiment.
Well, funny you say that. I debated a guy who argued its correctness staunchly.
Did you not? Wait, you must have watched that in the McToon, Alan. I wouldn't even call it a debate. The structured recitation, I guess.
Yeah, man. Let's see here. So yeah, the A.G. Kelly paper was awesome. So it goes over the Einsteinian clock, the mythology of Einsteinian clock synchronization. Breaks it down pretty good, pokes a hole in a lot of the data. So that, like, for example, there was 4 clocks on the airplane, and when the plane was traveling, east, it was supposed to lose time, and when it's traveling west, gain time, that sort of thing. All the clocks were supposed to gain time and lose time corresponding to their direction, all of them. So what happened, though, is like 2 of the clocks would gain time or lose time, irrespective of the direction, right? So just right off the bat, not even in sync. They had to do a bunch of math magics to restructure the data. What do they call it? Post analyzation and something. Anyway, they literally restructured the whole thing. I have the original prediction wasn't even close to Einsteinian results, and then in 1972 they republished their data. Post analysis and consolidation. So right after that consolidation, they brought it within relativistic predictions within 0.07%.
So I'm trying to pick. Oh, go ahead.
I was gonna say, not to mention, there was 14 times the clocks had an air reading. So like, there's fluctuations obviously within the readings, but then there's times where it just fluctuates to a degree that's way outside of their air specs. They have no idea what causes it. The guy that made the atomic clocks, Louis Essen, he has no explanation for it either. He was like, it just happens, bro, and we just correct it, So there was that happened 14 times on the experiment. So like, the amount of stuff that they had to do to like even get it back to a relativistic prediction is sad. And they didn't. Here's the cool part. So 1971, that was their unpublished, or the unpublished stuff, refutes what they republished in 1972, where it just suddenly meets the relativistic corrections. But they didn't post what they corrected, like how they derived it, right? So nothing shady there, I'm sure.
Yeah, it seems fine.
Excellent analysis, Alan.
Thank you, sir. All right, where are we at now? Let's see. Oh yeah, so real quick on A.G. Kelly, something that he pointed out with the atomic clock thing. This was an awesome thing that I learned. So Einstein, with what he defines as an inertial frame, it's like, is uniform rotation, circular uniform rotation, is that an inertial frame or not? Well, he quotes it from Einstein's paper himself, which made me go back and read it. Like, yeah, he absolutely gives an example of a light clock. Basically, Einstein's describing a satellite going around the equator as a, for the reference frame. So like, the fact that people try and now say that a uniformly rotating device like a SAGNEC device isn't in an inertial frame is insane. Like they have to do that so they can bring in the general relativity effects, and explain it mathematically that way. Like Kobe was saying, or Toby was saying earlier, you bring in the general relativity for that one. So all cool stuff.
Pretty neat. Yeah, so I was just trying to talk to, or chat with ChatGPT 4.0 about the muon detection, and I'm just trying to figure out. It said specifically the value was first measured with precision in the mid 20th century. So I said, like, what was this first measurement? So yeah, what was the specific experiment? Because I wanted to find the specifics of when they measured this, quote unquote. And ChatGPT couldn't tell me. Said one notable series of experiments in this field was conducted at Columbia University in the 40s and 50s, blah, blah, blah. So when I said, you specifically said this value was first measured with precision in the mid 20th century using experimental setups. And I said, what was this first measurement you are referring to? And it says, I apologize for the difficulty in finding specific information about the first precise measurement of the muon's lifetime. Like basically it's just giving me the runaround. And like what I deduced from this is that there was no actual measurement. It's just all been deduced from theoretical physics.
I don't have or I have the paper, but it's on the screen now. This is the experiment. I can't remember what it's called off the top of my head. Let me see if it's in here. Time dilation.
It's just like I know the way that they like to layer everything. Like with Michelson-Morley, it's best to start there and start with where they tricked us there, and then I can go from there all the way up to LIGO. Like watch how they had to keep layering it on top of it, like keep layering abstractions on top of abstractions. So it's like I wanted to try and do the same thing with this. Like, what was their first measurement? How did they deduce that? But it's I guess I had to put some more time into it.
Yeah, 1963 measurement of the relativistic time dilation using the muon mesons or whatever they used to call them.
Okay, so did they have to account for seasonal variation and
there was a least reductional squared value situation? Like I don't want to talk about it. No, basically they just have an oscilloscope and they're just measuring energy fluctuations that happen in a really specific, like a really short amount of time in a certain magnitude. So they're just measuring for that, and they get things that are outside of those thresholds too, but they don't count those. So there's no big muon or whatever. Whenever they get those kind of readings, they just ignore it or whatever. So
they're hitting.
Yeah.
Go ahead.
It was muon prime. Is that what you're looking for? Muon prime.
Yeah. So they're basically just taking energy readings, and then the oscilloscope converts that into electrical readings, and then they get it just
turns out there isn't one.
Yeah.
They never found it.
It's all post-diction.
Yeah.
There's
no prediction.
Yeah, so it's like we're measuring something, and then they tell this cool story about how it's created in the atmosphere from this cosmic event, and then only through special relativity. Well, the muon would actually die. We only detected it because time slowed down for the muon, and the Earth contracted upward in every direction, so that we could detect it. Like, dude, it's crazy, bro. And this is what they get people with.
Loud, it sounds retarded. Like, but that's what they actually. I feel like we need a disclaimer at the bottom. This is what you actually believe, people.
Yeah, can we go back into that paper and can you show the relativistic math in there?
Sure. Let's see here, David Fritch. Let's see what we got. Relativistic math is my favorite kind of math. So I'm seeing a lambda right here. I'm going to assume that's some sort of contraction mechanism. Looks very relativistic. I can tell
by the symbol.
I can tell by the symbol that's not called the Einstein contraction. That's definitely called like a Lorentz factor.
After calculating, wait, what it even says right there, statistical standard deviation. Why is there a statistical? Okay, are they using a bunch of measurements? Is that what's going on?
I don't know. I didn't even read this paper, to be honest with you, bro. This was from McToon's citations, but I knew this was all dog shit, so I didn't even really read it.
Right there. Thus, not only does our experiment give direct qualitative evidence of time dilation, but the observed numbers support the quantitative predictions of the special.
Oh my god, it says it right there in point blank. Way to go, dude.
Literally.
Wow. Good
Observed
spot.
numbers support the quantitative prediction. So
The qualitative evidence.
It's exactly as we predicted.
you go up a little bit. I want to
So,
see the
hey,
top of
it's
that
like, hey,
paragraph.
we needed some quantitative evidence. Like, yeah, we got you. Here's some qualitative evidence and some predictions that we say
Rough
match up.
estimate. Look at that. Rough estimate of a factor of 9 for the time dilation.
Jesus.
That's one of my favorite estimates.
That's how you do an experiment right there, boys.
Yep.
You make all your assumptions beforehand.
This
Shout
paper
out.
actually makes me sick to read. As like, look what we deduced. What?
And
Dude,
make
that's
sure you use statistical
that's awesome. Where's that at?
frameworks to make it fit.
I'm gonna have to save this for the next time Muons comes up because it's way better to body it right from the source.
You should highlight it
Right.
all in pink though, so it's easier to look at or something. So you know it's like not just be
Dog,
taken serious.
dog, check your boy out. Oh, whoa. Oh, you were mocking my pink highlights, bro. Okay, bet.
Only a little.
All right,
Only a
well, it's
little.
all pink
It's
now,
gonna be
brother.
pink anyway?
Yep, it's now all pink. GG. Cool.
Yo, I gotta step away for just 1 second. Back.
Yep.
Nice. I appreciate your highlights. Your highlights didn't translate over to this thing.
Hey, speaking of highlights, check this out. I made this. Where's this at? For your boy Wang. 1 second. There we go. So I came up with like a highlight coordinate system to like show people that aren't familiar with the subject matter, like when they're talking about rotation, when it's linear, when it's rotational, when it's something that's really important, that kind of stuff. So I did almost the whole paper like that. Pretty much the whole paper. Yeah, I did the whole paper like that to kind of like make it easy.
It's literally a reading rainbow.
You think
Where-
you think
where
that
is
makes
your
it
D?
easier?
I mean, well, I have a legend that comes with it when I give it to people. Like,
Because honestly, I'm looking at it like, what the fuck, dude?
Oh,
Like,
man.
green, does green go with green?
Okay, okay.
Am I reading the green first? Do I go sequentially?
It's a good question. It's a good question. So pink is angular rotation, green is linear motion, blue is miscellaneous,
Oh.
black is stationary, red is emphasis on importance, and yellow is whatever.
Great. That's a wonderful system.
Whatever.
Yeah.
This reminds me of my Excel spreadsheets at work.
Yep. It makes sense to me. Like, I don't know. I could look at this thing and I'm like, okay, we're rotating, we're linear. All right. I don't know. Thought it would be helpful to
That's an
somebody,
interesting key.
but I guess
Is
not.
that key universal among your library on all the PDFs that you highlight?
No, but it should.
God damn it, Alan. Well, then what the fuck do I make of that?
Well, I can give you it just for that one, bro, and you can reference it. Yeah, I should make it universal though, huh? Since I don't know.
I immediately thought that must be the case, and immediately I was like astoundingly impressed. I was like, oh my god,
Dude.
I made fun of his pink highlights, and it's a wonderful, like, well thought out system of integration, and you can just reference it, and then you were like, nah, it's all different. And I was
Dude,
like,
well,
okay.
as soon as you
All right.
described it like that, I regretted not doing it like that immediately. Because every time I do a paper, so my deformed printer is all backwards too. Like blue is, yeah. Anyway, all right.
I mean, I've never been able to discern a pattern, and I've been looking, bro. So,
Dude, each one is unique to the paper.
That's
That's
funny.
a
I
great
definitely have
deal.
like a pattern with the videos that I edit. I definitely give certain words like certain colors.
Oh, that's awesome. All right, let's see. So E equals MC
He
squared.
has a random color generator.
I would use more colors if it wasn't more inconvenient to do so. But yeah, so just different coefficients to describe the distribution, right? And then they make different. So when it came to JJ Thomson, what did they do with JJ? They assumed the radius of the sphere that they were trying to distribute the energy over, and then they came up with the coefficient to distribute said energy, and then they had the charge, which they could measure. So once they have all that, they can like reverse engineer that basically. Once you have the mass and trajectory or velocity, you can get momentum out of that. So they can make they're making essentially like ballistic trajectory predictions of like particles based on how they're interacting with a magnetic or electric field, and then they're extrapolating how much charge that mass would have to, how much of that distributed charge would have to be over that mass to get that to deflect on this angle based on a magnetic field or electric field kind of thing. So the whole basis of particle theory and all that stuff all comes back to the electron right here, which in my opinion isn't a particle. It's the lowest amount of energy that they can detect with an apparatus. So they took that and the pressure mediation that ensues through that, which creates their the beam and all that, and the divergence that happens there. They took that and turned it into a particle, which works for certain cases. Like it certainly describes the hell out of this experiment, right? But then as years progressed in technology and all that stuff, when you could manipulate different variables and analyze things more carefully, their model started falling apart.
So I just kind of had a light bulb moment there. This is kind of unrelated, but kind of related to what you just said. So when they're talking about like double slit, and they're talking about photons being split into two of the same quantity photons, and then coming back together and being a one quantity of like the same quantity, but it's only one photon, right? What that really is just they're measuring. It's like the limit of their measuring capabilities.
Yeah, essentially, the way. Yeah, so a video from Danny Minley that I linked the other day, he said it really eloquently. So like the electron is like the baseline calibration for their instruments, and then everything that increases and has a different effect energetically, that's where they're like, okay, now this is where it's a photon, this is where it's whatever, right? So that's what they do there, because there's obviously never any particle, because a particle doesn't make an interference pattern. So an electron, makes there's electron interferometry, right? So there's no particle there.
Smallest they can measure. That makes total sense, dude. It's like, it's not a actual tiny unit of bubble flopping around that actually makes things. That's like, no. This is the smallest amount of pressure mediated energy that we can measure or perceive, and then we just build things based off of that, and it's constant.
Yeah, it gets down to a point where it's really just a matter of like a 1 or a 0, right? Like you can't go any lower than the 1 at that point. It's just either it detects something, or if it's too small, it just doesn't detect anything.
Yep. Yeah, and then so when they detect smaller things at different scales of existence, right, where it's like popping in and out of existence, so to speak, like a muon, they invent a whole new thing for that, and they're like, oh, this could only be blah blah blah, right? This is like a whole new thing, but it's the same energy thing, but it's just a different what's it called, like a different magnitude of it,
Mm-hmm.
I like that
Okay,
too.
yeah, that's really good. Okay, that was really good. I just learned a lot from that.
Yeah.
Especially when you start to think about quantifying waves through ether. You start thinking about that, and you're going to realize that you're going to have no like points where you have 0 readings, because the wave is moving in a way in which you're not going to detect the front or the back of it. It's in a state that's immeasurable, basically, because your state is not relatively different enough. I don't know if I'm making any sense with that. But like basically, if everything, yeah, if you're trying to measure waves, there's gonna be parts of the wave parts of the timing of the wave in which you're not, from your perceptive point, you're not going to be able to see you're not going to be able to read anything. If that's making any sense to anybody.
Are you kind of like saying if you had it on a scale of the peak is a plus and the trough is a minus, you're always going to have a 0, and the 0 is non-reading kind of thing?
I guess I have like a visual aspect of something. I'm thinking of like a really like, because if something's popping in and out of existence, I'm thinking that really what's happening there is there's some kind of elongated wave, some kind of elongated relationship that's so stretched out and long that you can't detect it until you get to the front and or back of it. Does that make any sense?
Yeah, I get it. I'm just trying to think of a way.
I really can't articulate it.
Yeah. No, I mean, saying it that way, I get it. I'm just trying to think of a better
Like
way
if
to
you
articulate.
thought of like an S shape, like the shape of an S, and then you stretched it out really, really, really long, it's like you wouldn't really be able to tell it's an S, and your detector mechanisms will no longer detect anything. It's just going to detect a straight line. It's not going to detect a curvature of an S.
Oh, I see what you're saying now. When it reaches that peak fluctuation for your instrumentation to calibrate.
Yes,
I mean,
yes, yes,
when
yes.
it'll measure. Okay, yeah, I got you, dog. That makes a lot more sense.
It just
So,
falls
like-
outside of the range, right? Like the human ear can only hear within a certain range. Above and below is just non-existent to us.
And so that to me would explain things popping in and out of existence.
Wouldn't it just be like a simple way that it drops below the threshold by which you can detect it? Maybe the
Yes.
energy is still there, but at a lower threshold that we can perceive. And then that's why it's sort of a wave propagation thing. As it goes, it ebbs and flows. And when it ebbs, you can detect it and it's past the threshold. And when it flows, it's just the opposite.
Yeah. So you know how?
The easiest part,
Go ahead.
yeah, the easiest parts of a wave to detect are the nodes. So you should look for the points where there is no motion of the wave. And if you can't find those, well, then you can't define the wave. But if you can, then that defines the wavelength. Distance between two nodes, or three nodes, I guess, is the wavelength.
Yeah, it's kind of like the easiest detection is the peak and the trough. And I guess I think of Walter Russell's idea or conception of a periodic table of elements being in a sine wave based on different octaves. And all of his elements reside mainly on the peaks and the troughs. And then there's different variations as you go towards the center point or the inertial line.
So looking at this right here, like that period where it's in the center there, right? And there's the antinodes and the nodes are basically undetectable. Like if you were to pause it in the middle.
Damn.
Like if there was some kind of a long like waves of that. I think you guys get what I'm saying. I'll stop trying to articulate.
Yeah, you got
I
it.
get what
We're
you're
all
saying.
on board,
Yeah.
bro.
We got it.
I posted a screenshot that shows what you're talking
Probably.
about. Yeah, when it's at the lowest amplitude. All right,
Hey, that's a good way to say it.
there we go. So yeah, if they had a anyway, that's cool. I don't know where we're at, but
I think we should go back to the huge philosophical and personal ramifications for the equivalencies proposed in the E equals MC squared thing.
That's a good idea.
okay, it's a good place to take it. So
Yeah.
let's see. So there was a huge thing with the mathematics of it all, right? And this isn't the right presentation. So there was a huge thing with the math of it all, like that implication of it, where it was just using abstract kinematics that could never be brought into dynamics because of the way that you could have the way that they had to account for the conservation laws after this situation. So this led into more mathematical abstractions that couldn't be undone. So by this time, after 1905, Einstein had spent like 40 years of trying to correctly establish this so that it would make sense in reality, right? And he could never do it. So he writes saying like, "Hey, can we go back to the old way and use that inertial mass?" And they didn't. They opted not to do that. And that corruption now has like led into everything where it's like, if you can explain something mathematically, you don't need to justify it or anything like that, right? Is that kind of what you were getting at last time, Shane? Like for the moral implications of it, for moral relativism?
Yeah, like metaphorically, or symbolically rather, like how Einstein can come along and take the importance of the lab frame, pivotal previously to all experimentation, measurements, and hypothesizing of a scientific nature. You can just take that, and with his E equals MC squared, energies actually matter. Nothing matters. Everything's equal. Everything can be something else. It's only a matter of reference frames. We can endlessly coordinate and transform back and forth. So therefore, nothing has meaning. So what he did when he came along and ruined that was symbolically pollute the mind of people and man, which spread from mathematics to philosophy to socialism to religion. This moral relativity. So now we have philosophical relativity, we have mathematical relativity, we have scientific relativity. Relativity has permeated culture so bad that we're now forever upended in a series of like a nihilistic plunge downward forever after him. Like that's the philosophical ramifications of E equals MC squared.
Well said.
Correct. I agree. I go on that rant often.
to the point where we can't even define a woman.
Right? That's his fault, dude.
Dude.
We can attribute that to him. E equals MC squared is directly responsible for that shit.
If you're in a different reference frame, is a chick still a chick? Like, that's just what we all want to know. Is there a mathematical derivation to help us establish this?
I know that when I was listening to your presentation, Alan, like I had that thought and I went, "Oh my god!" Or
Like,
I think
this is where it came from.
Yeah, I was like, "Oh, that's so important."
Dude,
the gravity of that.
that Atsutovsky book, man, like the first 3 pages, he's going over like the philosophical implications of delving into infinite abstract mathematics that has no physical meaning. I think there was a word for it. It was I can't remember, but it was a beautiful phrase. It was beautiful 2 words to describe it. The way that they're doing
String theory.
it. Yeah. But yeah, when they're not concerned, when you don't have to explain a physical mechanism and you could just reify it through mathematics, and then you train people that there is no medium or anything, just the mathematics, like nobody has to be in on it. Everyone will just assume that there's no medium, there's no interaction, and it's just in the mathematics. For example, last weekend, or it was a Friday, Witsit was talking to a CERN physicist, and basically the conversation got to the point where he was like, okay, so what's a photon? And he was like, well, it's an excitation within the photon field. And it was like, and where does that come from? Well, it's another, that's in another, that's stems from another excitation in another field. And it's like, so you're saying that the photon comes from an abstract mathematical field into another field? And he's like,
A localized point of a mathematical field.
yeah. And
is
he
what
was,
said.
yeah. And he was like, so, like, he didn't see the problem with it. You know, he was like, yeah, obviously, like, you know, because they're just not, people aren't, they have no idea that there's like, that there's an ether and there's like properties to it and all that stuff. Because he asked, like, he was like, well, what's the difference between my abstract mathematics and like what are the physical properties of the field then? And it's like, by not telling people that there's that there's another interpretation of these experiments and all that stuff, like that slide that that Bennett came through with on his presentation summarizing the properties of the ether from the Atsutovsky's work, is just like, that's crazy, man. There's literal math behind it, like explaining the same kind of shit. You know, we got kinematic viscosity, dynamic viscosity. So they were making predictions based like off of their kinematic viscosity. Bennett, is that kind of what that means? Like they're actually doing experiments based off of the ether, and these are their results, man. So like we have a whole framework here to like look into, and that's actually what my presentation is largely going to be. Well, it'll tie back into that, like, you know, sparking interest in researching the ether and all that. But that's what a large part of my presentation is going to be on December 8th.
Nice.
Nice.
So it's like we have it all right here. We have properties. We have repeatable science.
We're gonna have to pay for that once, Alan, so you get money, and then pirate it here and stream it for people.
I make no. I what? I'm lagging. Did you say something?
Nope.
I didn't hear that. The ether cut out. What'd you say? Anyway, we got we have the stuff, man. So hopefully it'll inspire people to get into it and all that. So to start off,
Yeah, when you really look at it and like think about it, it's really actually amazing to look at, because it's the cornerstone of like a whole new paradigm.
Pivotal. It's pivotal, but not only is it pivotal to us, it's been pivotal to them, and they've of course just bogarted it and they've repurposed it and subverted it to work for their ridiculous backwards engineered, reified, retrocompatible models. But they've convinced us, and they say it with such confidence that we're like, oh no, Michelson-Morley disproved the ether. It couldn't possibly be that.
Yeah,
It's
we have,
astounding, 'cause
dude. So it's like, where's the ether? Did Michelson-Morley disprove the ether? I don't know. Hold on, let's find out. Modern day particle physics. Muon G-2 experiment uses the Fermi Lab's most powerful accelerator to explore the interactions of short-lived particles known as muons in a strong magnetic field in empty space, quote unquote empty space. Scientists know that even the vacuum of space is never empty. What's that, you say? Instead, it is filled with an invisible sea of virtual particles that, in accordance with the laws of quantum mechanics, pop in and out of existence for incredibly short moments of time. Scientists can test the presence and nature of these virtual particles with the particle beam traveling in a magnetic field. The muon G-2 experimenters examine the precession of muons that are subjected to a magnetic field. The main goal of this is to test the standard model's prediction against the value of measuring the precession rate experimentally to a precision of 0.14 parts per million, which is that's exactly what it is. It's one part per 14 million. So there is an inconsistency where they indicate, or if there is an inconsistency, it would indicate the standard model is incomplete or needs revision. So that's so there's a sea of there's no ether, guys. The Earth isn't moving around the sun through the ether. It's moving through virtual particles that are detected by the mu minus G2 experiment.
Yeah, but Alan, don't you know
Jesus
they use we know it's real because they use Monte Carlo simulations, and these are crucial for modeling the complex processes involved in particle physics experiments, blah, blah, blah.
Listen, Toby, there's
I'm
the
yawning
least
already.
regressional
Anybody-
squared root method that we apply to make sure that we're not cooking the books, man. We have set parameters.
Data analysis frameworks. After data is collected, it needs to be analyzed and interpreted. Root, developed by CERN, is a major tool in this area.
Actually, could we just run that through my 5 embedded layer tertiary neural net where I can do some recursive programming and refine it back to a predefined model, and then I can get that data right back to you totally unmolested?
Last time we did that, you discovered the Shane particle, and we had.
And then we
we're
had
not,
that announcement. That's
we're
right.
not trusting you with that again. We have to do it for traction. We're not doing it again, man. But yeah, obviously we're going to do it
Root
again.
is open source. That's pretty interesting.
Yeah, we can discover a Shane particle, it turns out. So get that
Say
open
Root
source.
is open source.
Yeah, their analysis
Oh shit.
framework.
Okay.
Yeah, so this muon particle accelerator experiment, you guys remember back to this experiment here with the cathode tube?
Mm-hmm.
Super scientific, grounded in no assumptions.
Same thing, dog. Same thing. They've never stopped doing this. They've always been doing this.
Yeah.
This big circular ring thing here that this is traveling, this is the same thing. Just a circular glass tube.
I think what Toby said earlier is probably super important. Right? It's like once you realize and you can like unwind it back to the first mathematical abstraction they make from the first misinterpretation of the actual measurement, which usually supports us, then you can backtrace it all the way through the different layers of abstraction they've had to pile it on since, as every person has like to go through. Like, okay, well this doesn't work. Okay, new mathematical abstraction layer. Oh, this doesn't work with general relativity. Oh, now we got special relativity. Oh, now new abstraction layer all the way to today, where we have this ridiculous tangled mess of, as Tesla put it, equations that have no relation to reality.
Well said.
I think it was Napalm talking to Kosho and Jace in GeoServer, and he was talking about there's like over 120 different quantum fields. It's like ridiculous.
Only Globers say stupid stuff like that, dude. That's what I find.
It's so
So,
crazy.
so from my understanding, in quantum field theory, everything is broken down into an individual stationary field. So I think, yeah. So like there could be more, right? No, like I don't know. That's crazy.
It's ridiculous.
So I see Root is the data analysis framework, but that's open source, but the actual analysis code they're using is not open source from what I could tell.
Oh,
Like it's just I was really excited to look.
You can see how the bot responds to you, but not how we analyze the data.
So yeah, it seems as though in like the quantum realm, each particle that they quote unquote discover has its own field. There's the quark field, the muon field, the gluon field, the electron field. Every single thing has its own field, and certain fields interact with other fields. But they never properly define the fields. The fields are just technically mathematical or as they say, it's strictly mathematical and has no physicality. They just have the energy within the mathematical field, but they give everything its own field and a field of probability mathematically. What they're avoiding saying is that each one of these fields is just a different vibratory scale of the one field. And so this is the way I break it down in my head, right? Exactly. The ether, right? And the different vibratory frequencies within that ether where you see manifestations of energy, quote unquote, popping into existence. Certain frequencies of those fields can interact with one another, thus like amplifying or breaking apart or destructing certain fields, kind of in the way that sound would do something very similar.
Overlap or like, yeah, exactly.
Right.
man.
Or EM can do the same, right? So you can have an amplification, or you can have a reduction. You can look at it as like octaves or certain notes, things like that, and you have these different nodal points that can amplify or destruct. And the only way that you have change or movement within that system is when you have the non-harmonies that forces the harmonies to shift and move. That's the way I look at it. It's all one
Yeah,
field.
man. That's a really eloquent, detailed way to explain the. I think what we were saying before was the same, right? If they were talking about matter and chemicals and the like chemical table driven by electron layers, then we're just talking about literally things changing as different layers of pressure mediation driven by electrical impulses, right? So then the whole world being electrostatically driven and charged, and then only divided by hierarchical electrical divisions of pressure mediation. It's just called different things for different people.
Yeah.
Yeah.
Some people call it quantum fields.
Yeah. No, and when you take it back down to the quantum level at the highest levels that they say when they try and describe these tiny little particle, dude. So get this, dog. They invented two forces, the strong force and the weak nuclear force, to describe these particle interactions. And they had to describe it by inventing little smaller particles to facilitate that. Yeah, to facilitate that, dude. So like it basically got down to the point where they call it color pressure mediation, and it's like, what does that mean, dog? Are you just trying to avoid using the word frequency? Is it frequency based pressure mediation, dude? Like, is it a vortex? Are you just describing a direction of flow? Are you just fucking with me? Is it not a particle, dude? So
That's what they want to do. They want to say color charge or like a up quirk, down quirk. Like they'll give it all these other names to avoid any association with one specific field in different vibrations.
Yeah.
Like that's the other philosophical negative ramification of E equals MC squared is that it tainted science and forever sent us down this wrong trajectory of misled nonsense where we're chasing non-existent particles and probability clouds and trying to do science and make measurements in quantum fields and things that we have no fucking idea, instead of going back to proper driven electrical field theory where we can make like improvements in measurements and actually like, you know, progress. That's the damage, right? That was intentional.
Vortices versus atoms. Let's go.
Yep.
When you think about the scientists sitting there measuring variance in the speed of light and saying, "Hey, we didn't get any variance in the speed of light," and shaking each other's hands, it's like that's
circle jerking. Yeah,
exactly what you're explaining right there, Shane. Yeah.
Yeah. So to top that off here, we have J.J. Thomson, 1883, a treatise in the motion of vortex rings. So this was him trying to develop the mathematics to describe the fluid dynamics of a vortex, right? So it will be seen that the work is almost entirely kinematical. We start with the fact that the vortex ring always consists of the same particles of fluid, the proof of which, however, requires dynamical consideration, and we find that the rest of the work is kinematical. This is further evidence that the vortex theory of matter is a much more fundamental character than the ordinary solid particle theory, since the mutual action of the vortex ring can be found by kinematic principles, whilst the clash of atoms, quotations, in the ordinary theory introduces us to forces themselves which demand a theory to explain them. So he's saying that you can use one fundamental principle, right? You take your one assumption. The vortex ring consists of an incompressible fluid, right? And then from that, they can do all these mathematical predictions and basically get it to fit. And then, so for the particle theory, they had to invent the weak force and the strong force, describe this insane charge distribution that's 130 times stronger than gravity. And they don't even, so to analyze this framework, they don't even incorporate gravity. That's why they're like, oh, when we're down on the quantum scale, dog, we're on that strong and weak nuclear force, so it's way stronger than electromagnetism and gravity and all that. And then except the weak force is not as strong as electromagnet. It's so dumb. So they just invented these to reify their position of atomism. And then so they tell everyone, hey, we're looking for the graviton, guys. You know my boy Gravity. Shout out to Gravity, holding everything down or up or in free fall, whichever way you look at it. We're looking for that graviton. And dude, so if they ever found the graviton, it would completely falsify their model, because then they would have to incorporate it as a force in their calculations, which would fuck everything up. So they're looking for it. You know, I'm using air quotes. You can't see it, but they're not really looking for it. You know what I'm saying? Yeah.
Right.
They explicitly made this to not account for gravity, and they're like, guys, we're looking for gravity. Wink, wink. Maybe there's some dark matter that we could find. We all know dark matter is related to gravity, right, guys? Right? Remember Interstellar? Remember Matthew McConaughey? Remember dark matter? Like, dude, it's like literal memberberry shit. Dude,
that's why I like Whitsett's presentation of it as just like two comparative interpretive frameworks from which to view and interpret the phenomenon that is reality, right? Like a phenomenon can be observed in two different frameworks, and you could use atomism and believe in nonsense reification and probability clouds and photon things and particles and dualities and things that self-contradict, or you can do it from the etheric framework where things, it's not actually traveling, it's already there. Photon is just an event, an intercedence of like, the two interceding electric fields. Like it's easier. And when you can look at it like both interpretations at the same time, it's clear that atomism is retarded and that all their interpretations and predictions are stupid. And it's only in the absence of the comparative probability with the etheric version does anyone accept atomism at all.
Yeah.
Mm-hmm.
Well said.
Very well said.
All right, one sec. I thought I saw a graviton, but I didn't. So.
Well, it depends on what kind of matched filtering you applied.
Yeah.
Find it.
Do you feel like the search for the graviton is like one of those television shows where they're looking for like buried treasure, and it's like they're getting investors really hyped up about it. It's like, no, it's $7.8 billion worth of gold. We found this map, and it's going to be over here somewhere. I swear, we just need a little bit more money. We need to search a few more spots. We're going to find it. And it's just like they're fucking laundering money.
I mean, you just described LIGO, bro.
Dude, isn't that like what they did with weapons of mass destruction and like all the wars? We're going to find them over there. Nope. Now we got to invade Iraq. Oh, we're going to find them over there. Oh, now we got to go into Libya. Oh, we're going to find them somewhere. Turns out they were nowhere, but now everyone has a World Bank.
Dude, WMDs. Dude, WMDs are like the electron, bro. Like you can never find it, but like it's definitely in a cloud of distribution probability.
Just call it the MacGuffin of the day. We'll move on.
The Middle East cloud of probability.
Oh man, that's awesome. I love mixing physics jokes with international banking. Very cool. Very cool.
But we're still on YouTube, so you got to be general.
Yeah.
All right, man. So that's where I'm at on that. Toby, do you have any other E = MC squared things you wanted to follow up on, bro?
I don't know, man. I guess what I'm curious about now is the propaganda. Like when was it unveiled to the world, and how was it sold to the world? Maybe we need like, so there's no meaningful experiment from which it was derived, right? I guess so. I guess there was some point where Einstein published some paper, and then that was where it was like all over the news.
Yeah, so in 1905, that was in his special relativity paper, where he was, came up with the solution to redefine all of physics to explain the Michelson-Morley experiment and get rid of that pesky lab frame. So that was on the back of that paper where he didn't derive it properly, and
Holy
then
shit!
yeah, and then it was like further reified again in 1915 with general relativity when they were like, "Oh my God, look, boys, we looked out at the sky and our postdictions match our kinematic equations where we contract the coordinate system to fit proportionally to explain everything." And then they were,
I've been thinking of like parallel timelines this whole time, that this was like a separate, like, because logically it would have to be separate from their. Oh my goodness!
yeah, it was phase one, and then it was like tying them together with the equivalence principle, so it was like a double reification, and that's like it's nuts, dude. Like untangling this web is it's been quite a
I think
quite a
we
journey.
hit the ramifications of E = MC squared pretty hard tonight. I feel like we got a lot of that out in the open and said. And now now that people didn't crap on it as soon as I got it out, I feel
Well, you
much
just think
better
about
about
it from a child's perspective of growing up. You start asking questions about the world, and you start being told these crazy paradoxes about like the twin paradox and the speed of light, and uh, like an atomic bomb explosion coming out of an atom, and like which I don't know. That's not. I don't have quite as big of a problem with that as I do the other things, but uh and the absence of a background medium, you just assert this, like, this emptiness, this lack of between everything, with no possible means of being able to assert that. So are told all these things. You're told about infinite skies that stretch out with infinite nothingness between it all, and you grow up thinking that. But then you also, let's say you were brought up with a religious background, like you have cognitive dissonance right there with anything that you would get within a church or most
by
spiritual.
design. Yeah.
Yeah. So and it's like, if you spend a lot of time contemplating those things, you start thinking about, like, well, gosh, I can't even get off of this planet that I'm on, that's like that's infinitely just in infinite nothingness, and it's just gonna rot away to a rock someday. I can't get out there anywhere, and even if I did, if I go faster than the speed of light, then I'm gonna leave my timeline behind. Like, you can't travel without leaving your timeline behind, because if you go faster than the speed of light, the earth is going to start you're going to start going faster than reality, and reality is going to get old while you're traveling. It's just like
Well,
the levels of it literally makes life meaningless, is what I'm trying to get to, because there's no universal truth. And once you take the universal truth out of the brain, once you take that little chunk out of there, it just, like you were saying, Shane, it just kind of slowly starts seeping into everything else with philosophy and morality. And it starts, like, everything starts to become relative. And it's like, we clearly live in an extremely postmodern world. And I think it has everything to do with where science has led us.
Yeah, I agree completely, man. And the propaganda goes deep. You were asking before, like, where did this propaganda start? What is the propaganda? I mean, it's still going on to this day, even when you think about the ramifications of the E = MC squared, or at least the alleged ramifications of it. And, we even recently have the movie Oppenheimer, the constant reiteration that we have atomic bombs and that you could blow up at any time. And this fear that gets implemented, which we know is very easy to control people with those mechanisms. So the propaganda continues on and on. And as you're seeing, yes, we have this moral relativism that is permeating into our society as well, to where you go out on the street and you talk to the average person that's, say, 30 years old, and you ask them what they think reality is, and they're probably going to say, well, for all I know, it could be a simulation, and why does anything matter anyways, right? So they have this
exactly.
underlying
Oh
fundamental
man, that's why.
disconnect.
Are
Yeah.
That's
Yeah.
exactly what my mom said whenever I
And
brought Flat Earth up, and she's like, she tried to play the whole, well, what if it all doesn't really exist anyways? I'm like, do you feel pain?
Well, that,
Yeah.
but now you know that's a programmed nihilistic response as a direct result of the social
Correct.
engineering and conditioning that Napalm was so
Yeah.
eloquently outlining.
Yes,
no,
exactly. That's
hang
what
on.
they're programmed to respond with, right? As a shutdown like trump card to anything that could go
Yeah.
opposite to the mainstream. You know,
And like
it's
Schrodinger's cat, right? Like it's like that's exactly what it is, really. Like at the end of the day.
Which, sorry about the soundboard thing. I thought the excuse me was going to be a very well timed excuse me in response to what Toby was saying, but it was.
Dude, you're gonna make it worse, but it's good to see you back, Brandon.
It went over my head, so I just kept going.
we all
That's
missed you,
fair.
bro.
I just wanted to apologize.
Welcome, man. Good to have you here, Brandon. Been a
Thank
long
you.
time. Didn't
Yo,
even realize that was you over there.
Welcome
Yeah,
back.
man, stuck in.
Saw y'all all in here. I was like, hey, I saw that little ping for the round table earlier, and I was just eating dinner with my family, so I couldn't do anything about it.
Yeah, this is
But
the only
yeah.
time I'm on Discord now. Tuesday nights with Aether Cosmology Roundtable.
Bro, all the cool stuff happens on a Tuesday. There's a song about it.
Is it really?
Like my birthday. You
Well,
know?
the last 10 Tuesdays for damn sure that's been true. Yeah.
It's been it's been dope. I'm glad to be a part of it.
Yeah, I unfortunately am typically tied up on Tuesdays until about this time. You typically on Tuesdays, but fortunately this week I'm not tied up. So
You're doing like 7 things, working your job, playing one of your 4 sports, or coaching your kids. Yeah, that sounds crazy.
yeah, coaching the kids on Tuesdays. But yeah. So not tonight. But no, I mean, when you think about the ramifications of this ideology and how much it does permeate through culture, and it just keeps getting reinforced. When you think about Einstein coming onto the scene, roughly around the turn of the century, when we're starting to get our whole entire electrical grid, and we're getting all this great innovation that's coming out of the end of the latter end of the 1800s, right? And we start to get into the 1900s, and then we have Einstein come on the scene and kind of really shut down and move things into a different direction and completely change the foundational basis of what people were working with previously when it comes to electrical field theory, ether, all that kind of stuff. You see a quick, transition into this war mindset, right? Which helps kill off a lot of people, gets people scared, gets people completely jumbled up, right? And then another war quickly after that. We have the scientific revolutions that came about allegedly from the Nazis and all that kind of stuff, which were working with different types of technology. But throughout all of that, you have this overlaying of we're using this fundamental foundation that Einstein put forth to create the scariest, biggest bomb in the world. And then you have that going all the way up into, through the 1980s, up into the 1980s with the Cold War and the threats of this technology and what could happen if it gets in the wrong hands. And are we
Oh my
using this?
God.
You know what I'm saying? And it just
That's
keeps
such a good
going and
point.
going and going.
That's such a good point. I didn't even connect those 2 dots. I just watched Oppenheimer the other day to get my daily dose of propaganda, and I hadn't even connected it. That's perpetuated off the back of E equals MC squared. One layer of abstraction after another. We're making a fake weapon off a fake equation from a mathematical abstraction from an interpretation of an atomistic framework of nothing. Holy shit.
And for you kids that are too young to not grow up in the 80s and remember that there was a Cold War that was taking place because of nuclear threats, don't worry. We'll talk about, some other countries around the Middle East that have nuclear weapons, and then we'll give you some propaganda in the movies to tell you where they all came from.
Yeah, I was just watching the Joe Rogan with Eddie Bravo about nuclear weapons this morning. Actually, it's kind of surprising I came in at this part of the conversation because it was hilarious how triggered they were getting simply because Eddie Bravo was like, but what if? He wasn't saying they didn't exist. All he said was, what if they didn't exist? And he's like, just go to your priest. Just you just find out. Go to college and find out. It's like, oh, go to seminary school, right? Just do it.
There's gaslighting.
Yeah, it was. I enjoyed it. I mean, I couldn't watch the whole thing, but I enjoyed it. What can I say?
Is that a recent episode?
I don't know. I was someone else was streaming it in Northern Rebellion's 5.0 server, and so I was just kind of chilling.
They showed the footage on Joe Rogan of the atomic bomb, where it showed like the toy car house fucking footage.
Yeah.
The
So
car just popping in, and then even
Yeah.
Joe was just like, "Oh, that's sus."
Yo, Alan, did you want to go on some quantum stuff too?
Not yet.
or
Okay.
do we want to?
Not yet. Yes, probably wrap it up.
Yeah. Got to keep them segmented. We can't. I mean, Alan likes to do 7-8 hour streams. He'll send it all day, but you know, I don't think my
Yeah,
audience
I
will
was
watch.
ready to
more than
open that
2
can of worms personally.
Yeah, but we're all the diehards, you guys. You gotta. Most viewers aren't us. They won't
mean,
binge
I
watch
saw
the
he
whole
had-
series at once. You know what I
He
mean?
had
Like,
the Vortex video pulled up, and I feel like we at least got to watch that.
Oh, where's it at? Yeah, do you
that's
guys want to watch
32
them?
minutes.
You guys want to watch them?
I think it's in your
short
Ether
ones?
presentation.
Oh,
Let's close it out with that.
Okay.
Pretty
Okay.
tight.
Ether
I don't think we
presentation.
can seriously get through a 32-minute video if we keep commenting. That'll be an hour and a half.
No, yeah, not, not that. No, it's just the thing with the vortexes. There you go.
This?
Yeah.
Oh, your girl Fractal Woman. Okay, bet. Yeah, let me pull up the actual video since we're.
It's not.
since-
That's
since-
not Fractal Woman, is it? That's Physics
No.
Girl.
Yeah, you're right. I'm sorry. You're absolutely
Ooh,
100%
Oh.
right. 100% right.
We called you out.
Don't be associating Physics Girl
Oh.
with my Fractal Woman. Come
Oh
on.
shit! My bad, bro. My
I'm with
bad.
you, Napalm.
My bad. Physics girl. Dude, that's so funny because I remembered it as a Fractal Woman video, and I went to her channel looking for it, and I found a video about magnetism that was way cooler and explained magnetism in a way. And I was like, dude, that's awesome, but where's the Vortex video? And I was like, oh, it's this lady.
Dude, it was like
Girl.
it was like 2 weeks ago or something like that, where you mentioned like, oh, there's this Vortex video that Fractal Woman just put out and blah blah blah, and I was like, I was listening to you say it, and you had just obviously misspoke. So I went onto her site and I'm like, looking, I was like, what are you talking about? I'm not finding this video. Like, what the heck? But then of course I got caught in the rabbit hole of going back and watching a whole bunch of her videos that I
Yep.
hadn't seen in a while.
Yep. Yeah, she's awesome.
When I drag the plate through the water, you
All right, here we
All right.
go.
All right, so
No sound.
oh, 1 second, I got you.
You gotta switch it. Yeah.
Well, a 4-minute video. Oh, I'm down for that.
Hell yeah. And it's gonna get even shorter.
Parts of it, right?
Shane wants to go watch.
can see
the
it forming little vortices, like you get noticeable
All
dips in the
right.
surface of the water.
So, preface for the video: there's a pool of water. She has a plate in her hand. She drags the plate across the surface of the water, creates 2 rotating vortices. What can we learn from this? Let's see what happens.
Why don't they die out? And how do these dark spots form? And why do the dips? But
Ooh,
look what
that's a
forms.
new
Perfect
look
black
at
circles on the bottom of the
parallels.
pool. And it's so weird. They don't die. They just keep going right next to each other. I sped this footage up because the circles took 3 minutes to cross the pool and didn't seem to be dying out. These got sharper as they went and made it all the way across. So cool. And look closer. You can see what's causing them. There are 2 almost unnoticeable dips in the surface of the water. Why don't they die out? And how do these dark spots form? And why do the dips move together? So many questions. Let's first look at what they are. When I drag the plate through the water, you can see it forming little vortices like you get when you move a paddle through the water. A vortex is a gas or liquid moving in circles with what we call a vortex line going up through the circles. They are everywhere. Tornadoes, water flowing down the drain, hurricanes, or the movement of air over an airplane wing. Vortices
off the
often form when
golden
there's a difference in
ratio
fluid speed,
and-
like fast wind.
Dude,
Velocity
literally.
sequence,
Dude.
etc.,
Dude, is
etc.
it supposed to be this fast?
Fine. Yeah, I got it. Oh,
Yeah.
absorb me.
Yeah, dude.
Things
Physics
moving
girl,
over
he
slow.
talks fast.
Yeah. I mean,
A little
Beasticles,
slower.
you got to train yourself on fucking.
Dude,
I
yeah,
feel
you-
like it's
Otherwise,
unhealthy. I feel like it's unhealthy for conversation.
bro, if you
You're-
guys
you're the
weren't, if you guys
minority.
were okay with it, we'd be on a 2x, bro. Like I can't listen to a video on the anyway.
Alan's time is too valuable for that.
As you move the plate forward, the water
All right,
right next to the
this is too
boundary
slow.
moves with the plate because of friction. The water further out is not moving. It's that difference in velocity that causes a shear force and starts the water spinning. This is accentuated by the water in front of the plate being forced around the sides and the water behind the plate being sucked forward as the plate moves along. In this coherent vortex, our dips can travel much further across the pool than a ripple without dissipating. Why? The vortex wants to keep its angular momentum, so it continues spinning as it moves through the water and only loses some energy through friction to the surrounding stationary water. So what we appear to have here is 2 vortices moving across the pool, but it seems weird that they stay right together. Well, when we create this vortex, we're forcing water to move around the whole plate, not just on the surface of the water. Our vortex line is curved. We're creating a half vortex ring, you know, like a smoke ring, bubble ring, or even the plume rising up from an explosion, but half of that. These 2 dips on the water surface are just the ends of the half ring. They're connected, and that's why they stay together. We can see this if we put a little food coloring into the ends. The food coloring travels from one end to the other, and you can see the entire half ring. So cool. We just made a bubble ring without the bubble. This also tells you something
I'll do, but wait, it's gonna get crazier, boys.
Food
interesting.
coloring
The half ring is
solves
not a weight.
everything.
What's that?
It helps that she's pretty, right?
Food
Only a
coloring.
little. Yeah.
A wave is a disturbance moving through a medium that transfers energy but doesn't transfer matter. When we added food coloring, we saw clearly that the vortex is transferring matter just like a smoke ring does. So sadly, it's not a wave. It's cooler than a wave. Now back to this half-ring vortex. Isn't it weird? You've probably never seen half of a smoke ring before. Why? Well, according to Helmholtz law, a vortex line cannot start or end in a fluid. So a vortex line either wants to close into a loop or end at a boundary. If you tried to cut a smoke ring in half, it would either break up or even cooler, it would break up into two smaller smoke rings. I don't know if that happens. It would be awesome. Since the line can't end in the fluid, it ends at the surface. You almost never see these half vortices though because they have to occur on the boundary of two media. If you can think of another way to make the entire half ring visible, like a smoke ring or a bubble ring, let me know. So now why does our vortex create those cool dark spots? Well, the balance between gravity, centripetal forces, and surface tension creates a funnel.
All right, not super relevant at the end there.
The choice of yellow food coloring in the pool probably not the best.
Not
thought
the
it was
best.
green.
Not the best.
Oh,
there was
man.
there was a lot of comments about the yellow choice.
I thought they were
This
gonna
just
do comparative predictions for comparative back to Newton's bucket in the shape of a vortex in motion, but nope.
Well,
Nope,
I
it
mean,
wasn't that at all.
well, it kind of is though
That-
because motion in the pressure mediation from that motion naturally forms a vortex, which forms so it's all vortex related. So anyway, to complete that two-dimensional representation of what she was looking at, so the two rotating vortices, right? When they're analyzing their in their model, and they're like, okay, we have these two things that are next to each other that are charged. How do we explain that they're not repelling or anything like that, right? So they invented strong nuclear and weak nuclear and all that kind of shit, right? So if they're just two vortexes that are connected, but they're not seeing like the connected part, right? Like they're just looking at this change because, well, actually, I guess that is relevant. The ending part. So the like what they're looking at when like light interacts with that part of the vortex, like it's creating that gap in the field that they're seeing or whatever. So they're internalizing that as like, oh, the proton or photon or whatever have you must be in here and all that kind of shit. But they're literally just looking at connected vortexes that are rotating together, interconnected vortex rings. What's up?
That one's a really cool picture right there. You can actually see the vortex at the top, like not just the ring, but you can see the lines of the vortex where it's thicker and thinner.
Yep. So from the reflection of that, it kind of completes the vortex ring, like as if you could see it, in from a three-dimensional perspective. So yeah. And then as she was saying in the video, when she played the clip, like the montage of all the different forms of pressure mediation that takes the form of a vortice or some sort of vortex, storms, all that kind of stuff, drainage, like pressure, a bucket spinning,
So wait.
Yeah.
So does that mean it's connected? Think about
What's
it like
that?
this, right? If that's a vortex, right?
Mhm.
Would you expect to see, I guess, like an anti-vortex? I guess you would call it. Like, okay, see
Counter
how
vortex?
counter vortex. There we go. So
I don't know.
So they're connected. They're both going the same direction. But normally they would repel from that, but they don't. So it's like to explain that in terms of like a physical model, they invented, little smaller particles with charge differentials. But from the vortex perspective, they're just connected. Right? So
how does she make the two vortices?
I'll show you. She drags a plate through the water.
Check this out. I'm just going to drag this plate through the water in the pool.
Okay, so one motion.
That's it. But look what forms. Perfect black circles on the bottom of the pool. And it's so weird. They don't die. They just keep going right next to each other. I sped this footage up because the circles took 3 minutes to cross the pool and didn't seem to be dying out. These got sharper as they went and made it all the way across. So cool. And look closer. You can see what's causing them. There are two almost unnoticeable dips in the surface of the water.
Okay, I got you. All right, so that plate putting force forward would cause the vortices to form on the other ends of the plate.
Yeah, the absence of there, right? The vacuum of the water, the rushing in of the water to fill the vacuum is what puts it in motion, which causes the vortex motion.
Right.
Are you trying to say that one's going clockwise and one's going anti-clockwise?
I'm just trying to think in terms of hurricanes, right? If
Oh,
Or counterclockwise, I should say.
well, I'm just
Sure.
saying is there because she made 2 of them, but they were connected.
Yeah, so check this out. I got you,
Okay.
bro.
I'm trying to like put it
Yeah.
together right now.
Have you ever taken or been smoking,
Thunderstorms are able
anyone,
to
random, whoever, but been smoking
search
in
for a
like the
trigger.
morning when the sunlight is shining through some blinds or something? Most of the room is like shaded, and you see the smoke vortexing through. The only reason you can see the vortexes is because you have the contrast between the shadow and the light.
Mm-hmm.
I don't know. It might be a way to help you conceptualize it all.
No, I'm getting it. I'm just trying to understand the physics behind it, especially with hurricanes.
Yeah, so I got a tornado video where they kind of go over the vortices situation and describe it. So you're right. There is a what you're bringing up. There is a counter vortex situation that happens, and let's look at how they explain the situation.
One of the
your
primary
stream's paused.
suspects has been a burst.
Oh shoot, yeah, my bad. I changed thingies. 1 second. You should be able to hear it now. I was wondering why nobody heard it. I was like, okay, it makes sense now. All right, so I kind of skipped ahead here. So basically, they're going over like the basic rendition of what causes the storm, and then they get into the 3D modeling of the vortex of the pressure mediation that's ensuing in the storm.
In a very short period of time in order to make a tornado.
In the search for a trigger, one of the primary suspects has been a burst of air descending from the storm, called a downdraft. The idea is that the downdraft wraps around the storm, tightening and intensifying the rotation.
We think the downdraft is really important for producing the tornado because it helps sort of
That shit's
squeeze
weak.
the air from near the ground up into the updraft. The air wraps around and sort of the downdraft kind of comes around and squeezes the air in the front and the back together to kind of squirt the air up off the ground.
Yeah, it doesn't squirt the air, guys. Just a heads
In the
up.
minutes before a twister forms, storm chasers often see a downdraft blasting a hole in the clouds toward the rear of the storm.
Well, it's a very impressive storm. So far, there's still no tornado, but the structure looks quite good. We're seeing a very strong RFD coming down. On the radar, it's still looking pretty good.
I used to be obsessed with tornadoes as a kid.
But just as often, a tornado
They're going to get
fails
into the modeling here
materialize.
in a second. I'm just building the preface to it.
There must be more
No,
to the
you're
story. In addition to the downdraft, Lou begins to discern a more subtle trigger for the tornado. To his surprise, the model reveals that just as the storm intensifies, a series of whirlwinds forms at ground level. These tiny corkscrews of wind merge together into a much larger vortex, the tornado itself. The whirlwinds that show up in the computer are so subtle, in real life they'd be invisible to the naked eye. But is there any evidence they exist in nature? Howie Bluestein believes there is.
We've been able to actually catch tornadoes in the act of forming with very, very high resolution. And what you see a lot of small vortices. You don't see one vortex becoming a tornado. You see a number of small vortices.
And the data proves it.
Very chaotic and it's very complicated. It's not just a simple little downdraft here and just spins itself up. There are lots of things going on at the same time, and that, I think it captures a lot of the complexity that we see in the real world.
All the evidence is pointing to an amazingly intricate dance of wind and moisture, interacting with the environment, including the terrain itself. The smallest changes can have a ripple effect in the atmosphere and can make the recipe just right for a tornado.
All right, very cool. So what they were showing though is kind of how you were saying that there's like a merger of the vortexes. It just
Right.
like the initial motion creates like a vacuum vortex, so to speak, that gets filled and it just kind of starts self-perpetuating.
Right, and it just breaks down into smaller vertices or vortices.
Yep, from which it was formed originally, bro. And then as those change, like, so that would be like you could look at that as like a change in the modality of the ether, right? So when they have like an electron and it interacts with whatever, well, that boost in amplitude, they're like, oh, that's when it releases energy and becomes a photon and becomes an illumination. Well, that's just changing the like that's just the vortice interaction where it's that's it. That's what I think it is.
Yeah, that makes sense.
Where they collide. Let me see if I can pull that one thing up real quick. There was a really good one from.
Because you know what a tornado still is, no matter what. It's still air. It's just a different. Right? It doesn't change. It's still air.
But if that air is blowing a Volvo, Napalm, has the air changed the modality at all?
I was just gonna ask if anyone else saw the fractal whenever it was showing all the smaller vortices going into the large main one. It was like real world fractal. It was pretty cool.
Yeah, those bug me out. The code for them bugs me out because like it should have a beginning and an end, and the fact that I can't tell bugs me out. You're like, okay, I know it's like a 6-second loop, but I can't for the life of me tell when that 6 seconds begins, man. Wow. Anyway, what else we got? We'll wrap it up. E equals MC squared.
Yeah, we're gonna watch
that?
We're gonna watch two vortexes collide real quick and then call it a day.
Sounds good.
The agenda tonight anyway. Oh, I just read it now, guys. Sorry, I'm behind. As we discuss Einstein's theory of mass energy equivalence. Oh yeah, so nailed it.
Oh my bad, not screen sharing. Okay, here we go. So there's no audio for this. No audio required. So we're gonna watch this vortex collide. Two vortices collide.
Is that like what happens when the Andromeda galaxy slashes into the Milky Way galaxy in 73.2 trillion years?
It'll be very similar to that. And but yeah, so basically when two vortex rings collide, it makes two well, not two. It makes a whole other section of vortex rings that are perpendicular to it, and then they flip, and they don't know why they flip. Like he talks about it in the video. I'll have to go back to the exact timestamp, but like, so watch what happens here. Slow it down even more.
Wait.
I wish I saved the timestamp.
Yeah, I don't think I'm seeing
44 sec. 4 minutes 44
We see the
seconds.
vortices on the outside, right? The
Yeah.
ones that form along the edges.
Yeah.
That's what you're saying is flipping, right?
Yeah, there's a more distinct version of it later on. Maybe it was right here. Yeah, let's try
Oh,
this.
there we go.
Let's try this.
You need like those super slow-mo, like 10,000 frames a second shot.
Well, funny you mentioned that.
That is quite beautiful.
Mwah.
It's just so perfectly symmetrical and yet chaotic.
Yeah, so it just makes smaller fractals of itself. Oh, dude, there's this. Oh man, I got super into vortex rings. So there's Anyway, let's wrap it up, guys. It's been a great it's been a great show. Thanks everyone for coming out.
And also, we'll work on getting out Bennett's list of suggested reading.
Yeah.
Yeah.
Yep. Absolutely.
Thank you guys. I'll catch y'all later.
Yeah,
Thanks everyone for listening, and yeah, come join the server if you ever want to join the discussion. Ether Cosmology, ethercosmology.com. Check out obviously Alan on Space Audits on YouTube, Twitter, X, whatever.
Yes, sir.
Thanks.
Yep. Peace. I'll be right back. I'm gonna exit my show. All right, guys. Thanks for coming out and hanging out. I hope you learned something and it was educational and it was fun for everyone. And got some subs tonight. Thanks to JJ Thompson. Dude, you're now JJ Thompson instead of J Justin Johnson. So shout out to Justin Johnson and Canadian Bacon who are now what are they called? Gravitational subs or whatever. They're under the gravitational influence or whatever. I haven't come up with a catchy meme yet to describe it, but we'll get there, I'm sure. And shout out to David Torrey, who tipped $10 on Rockfin. My man, thank you. Much appreciated. All right, for this week, what do we got coming up? We got your channel. Go to community. Let's see. For the rest of the week, live. For the rest of the week, we got, let's see, Thursday, I'll be live at 7 p.m. with Professor Rob Parks on his channel. I'll be streaming it here on mine as well. We'll be talking about my flat Earth journey. I reached out to him a long time ago, about a year or so ago, or maybe 2 years now, when I was early in my flat Earth journey, and he kind of wanted to do a not before and after, but like where you started, where you're at now kind of thing, to kind of catch up and see where things are at. And so I'll be doing that Thursday, and then on Friday at 5 p.m. I'll be presenting at the Mount Meru Season 2 Summit, and I'll be doing the full presentation of, let's see, The Lost History of Ether Physics, an introduction into toroidal field geometry. So that'll be cool. Check that out there, and you can find more information. I'll have the link in the description for the Mount Meru Summit stuff. You can go there, sign up. If you sign up under my name, I get half the money that you paid to watch the show. So that'll be cool. So do that, or sign up under your favorite content creator, and they get half of the money. All right, peace.